So I'm gonna like try to finish up some macros and blah blah blah. But like, I don't know. As Gary Cadell says, the guy that like made CPM, which was DOS, stolen whatever, legally stolen, like around Bill Gates. In his own words,
Our conversations were friendly, but for some reason, I have always felt uneasy around Bill. I always kept one hand on my wallet and the other on my program listings. It was no different that day.
so like, had your kids, had your wife, had your husband. Because Bill Gates is an opportunist.
Gates is more an opportunist.
Blackmail must be one hell of a thing for those Epstein lists to not be released. Damn, blackmail must be really strong, more powerful than money. Epstein flight logs, not released. I wonder why. I like how right here in his memoir it says,
It's only one example, but don't think for a minute that Gates made it big time because of his technical savvy.
yeah, no, Gates didn't make it big time because of his,
Technical savvy.
he made it big time because a major player in the game randomly died just out of nowhere. That's why.
Gates made it big time.
And so many other people. Like, you know, things about people. Or whatever. And like, I don't know, whatever. That's ridiculous.
Our conversations were friendly, but for some reason, I have always felt uneasy around Bill. I always kept one hand on my wallet and the other on my program listings. It was no different that day.
Yeah, that's not how you want someone to describe you. The person that, like, you have to keep your hand on the wallet because you didn't trust them. It says a lot about a person. I really don't understand how these people that run big tech get away with, like, it has to be blackmail. Literally, just blackmail. Like with Epstein stuff. Blackmail must be really fucking powerful.
A if is data descriptor. Target desk is true and target desk is false.
So I don't know. I'm gonna have a chatbot, not chatbot, Siri text to speech,
Throw a type error exception.
whatever part of the standard.
Target desk is true.
And I'm gonna try to get the macros done so I can finish up the C program that
True. Note, there is
runs the GPU shader program so I can make the stupid GPU shader so I can get back to working on the JavaScript engine
target object property.
and then get to the standard and like meet the standard and everything.
The property cannot set the value of a
It's all part of the process.
object property is enough.
And getting the GPU shader taking way too long.
As it's 0
Way too long.
10 p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, delete property if trap is undefined. Then, a return target p, let boolean trap result be to boolean. Call, trap, handler, target, p if boolean trap result is false. Return false. Let target desk be target p, 0. If target desk is undefined, return true, 1. If target desk is false, throw a type error exception, 2. Let extensible target be. Is extensible target, 3. If extensible target is false, throw a type error exception, 4. Return true. Note the proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call trap handler target. Let trap result be. Create list from array like trap result array string symbol. If trap result contains any duplicate entries, throw a type error exception 0. Let extensible target be. Is extensible target 1. Let tar get keys be target 2. Assert target keys is a list of property keys 3. Assert target keys contains no duplicate entries 4. Let target configurable keys be a new empty list 5. Let target non-configurable keys be a new empty list 6. For each element key of target keys, do A. Let desk be target key. B. If desk is not undefined and desk is false, then I append key to target non-configurable keys. C. Else I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do A. If unchecked result keys does not contain key, throw a type error exception. B. Remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do A. If unchecked result keys does not contain key, throw a type error exception. B. Remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note: for proxy objects enforces the following invariants. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This argument, arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert handler is an object. Let trap be. Get method handler. Apply. If trap is undefined, then A. Return. Call target. This argument, arguments list. Let array be create array from list. Arguments list. Return. Call trap handler target. This argument, array. Note: a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211, the 10th of May 2000.
Okay, so I think
New target. The internal method of a proxy exotic object O takes arguments list, a list,
I can glue this argument
and new target, a constructor.
to make this macro
Completion containing an object or a
pass in all the args,
RMS.
and they should call the function correctly.
Validate non-revoked proxy. O.
Hopefully. How long ago with this?
Construct
This took way too long.
is true. Let handler be O. Assert handler is an object. Let trap be. Get method handler. Construct. If trap is undefined, then A. Return.
I just want to get this done
Arguments list.
so I can get the JavaScript Engine done,
Arguments list. Let new obj be.
so I can play the game.
Array. New type.
There's too many people cheating.
J is not an object. Throw a type error exception. 1.
The cheating that the game needs to stop.
Invariance. The
It's not fair.
object 0, 5, 1, 4 validate.
Cheat. Get away with it forever. Like, no.
Validate non-revoked proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5. Proxy create. Target. Handler. The abstract operation proxy create takes arguments target an ECMA script language value, and handler, an ECMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except for and, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P. 12. ECMA International 2024. Note 1A proxy exotic object only has our internal method if the initial value of its internal slot is an object that has our internal method. 11 ECMA script language. Source text. 1.1 source text syntax. Source character. Any Unicode code point. ECMA script source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMA script source text where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMA script implementation process is the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code PO. Int. Conforming ECMA script implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals, and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMA script differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000A, for example, occurs within a single line comment, it is interpreted as a line terminator Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMA script program, the Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics. UTF-16 encode code point. CP, the abstract operation UTF-16 encode code point takes argument CP, the Unicode code point, and returns a string. It performs the following steps when called. Assert. 0 CP0x10FF. If CP0xFF, return the string value consisting of the code unit whose numeric value is CP. Let Q1 be the code unit whose numeric value is floor. CP0x10,000, 0x400, plus 0xD800. Let Q2 be the code unit whose numeric value is CP0x10,000, modulo 0x400, plus 0xDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string, text, The abstract operation code points to string takes argument
This is so annoying.
and returns a string. It converts text into a string value as described.
I almost removed a macro there,
Steps when called
but now I gotta like merge it.
text do
So,
to the string concatenation of result and UTF point CP
we do this to make this macro
1 1
the number 0, 1, 2, 3.
F16 surrogate pair to code point. The abstract operation UTF-16 surrogate pair to code point takes arguments lead, a code unit and trail.
And I'm removing the macro.
Code units that form a UTF-16 surrogate pair are converted to a code
It's called. So,
steps when called assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CPB lead 0x trail 0x DC00.
I can either pass it in
The code point CP1
and then call it
code point at string
with another macro
argument string a string and position
layer, or
the record with fields a code point a positive integer and a boolean. It interprets string as a sequence of UTF-16 encoded code points as described in 6 1 4 and reads from it a single code point starting with the code unit at index.
because I can't call the right hand side directly. I need another
The length of
level of direction
0 and position size
because the argument count is different.
position within string. Let CPB
Oh man,
is the numeric.
so stupid.
First is neither a leading surrogate nor a trailing surrogate. Then A return the record. CP 1 false 6. If first is a trailing surrogate or position plus 1 equals size, then A return the record. CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then A return the record. CP 1 true. Set
Alright, so I'll make another macro.
pair to code point. First, second 0. Return the record.
Call main
2 false.
or primary.
5 static semantics. String to code points. String, the abstract operation string to code
Not target. If you remember.
points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6 1 4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string.
And then when I pass in to primary,
Size. Let CP be code point at string. Position. Be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 111. 6 static.
will be V, W, X, Y, Z. So another argument.
Operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the
And then V
the errors were found
will be this macro that's concatenated, formed,
at the root of the parse tree resulting from
which is this.
return a list of one or more syntax error objects representing the parsing errors and or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 types of source code. There are 4 types of ECMA script code.
Which we call this,
Is treated as an ECMA script.
I think. I don't really care anymore. For fuck's sake.
Declaration, function expression, generator declaration, generator
It's supposed to be this.
and declaration, a sync function expression. async generator declaration, async generator
So V, the argument.
arrow function, async arrow function, class declaration, or class expression.
I'll just concat it before passing it in.
More precisely, if the parameter to the built-in eval function is a string, it is treated as an EC.
So it might possibly make more sense to read.
Particular invocation of eval is the global code portion of that script.
And I'll pass in WXYZ.
It is parsed to supply the value of the and internal slots. See 10.2 of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method declaration.
Alright, so this adds
Async arrow
one extra layer of indirection.
class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any, of that declaration or expression is also included in the function code of the corresponding function. Module code is source text, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized.
Which means I don't even need this.
Does not include any source. Note 1. Consider a text
I'm gonna need this.
particular point, and also a syntax error at a later
That makes more sense.
application that does a pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation
Because this is the indirection itself.
error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2000.
So it should run.
That is parsed as part of a nested function declaration, function expression, generator
Yes. Yeah.
declaration,
Oh, I don't need this either.
async generator declaration, async generator expression, method definition,
Alright, that should be it. It should work.
async arrow function, class
Please just work.
expression. Note 1. Function code is generally provided as the bodies of function definitions. 15.2 arrow function definitions. 15.3 method definitions. 15.4 generator.
Oh man.
15.5 async function definitions. 15.8 async generator function definitions. 15.6 and async arrow functions. 15.9 function code is also derived from the arguments to the function constructor 20, 2, 1, 1, the generator function constructor 27, 3, 1, 1, and the async function constructor 27, 7, 1, 1.
Oh, wait. No, it's fine.
Binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2, 2. Strict mode code. An ECMA script syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4. 3. 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains...
Ah, damn it.
Module code is always strict mode code. All parts...
Oh, so that sucks.
Expression is strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression,
I hate everything. Everything shit.
function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors as strict mode code if the last argument is a string that when processed is a function body that begins with a directive prologue that contains a use strict directive. ECMA script code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should
Try it again.
directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1, 1, 2, 3 non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA.
This builds.
Whether a function object is defined within ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments.
Is this already done?
The source text is scanned from left to right.
Dang it.
The longest possible sequence of code points as the next input element.
Gonna waste time.
Situations where the identification of input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar.
Nope.
Flashbang or EXP goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, J.
Okay, so I should be able to put this.
P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A.
Alright, now I got it.
Grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal S symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion. See 12.10 in examples such as the following: equals b high g exec, cmap, d, where the first non-white space, non-comment code point after a line terminator is u plus 002f, solidus, and the syntactic context allows division.
Here we go.
No semicolon.
This is it.
Terminator. separator. That is, the above example is interpreted in the same way as A equals B high G exec, CMAP, D, syntax, input element div, white space, line terminator comment, common token div punctuator right brace.
Finally.
XP, white space, line terminator comment, common token right brace punctuator regular expression literal. ECMA International 2024 217, capital I, N, P, U, T, capital
I need to get rid of this macro.
E,
Way too confusing.
R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment, common token regular expression literal template substitution tail, input element template tail, white space, line terminator comment, common token div punctuator template substitution tail, input element hashbang or EGXP, white space, line terminator comment, common token hashbang comment regular expression literal. 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher-level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMA script source text, these code points may also be used in an identifier name after the first character. U plus FF, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWNBSP. Characters intended for this purpose can sometimes also appear after the start of a text.
I think that's it. It's done.
In ECMA script source text, ZWNBS
I just want it to be done.
space character
Done. Everything done.
treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ
Finally.
100D 0
2.5 hours, I think.
ZWJ identifier part U plus FF
I removed a whole macro layer. Done.
218 ECMA International 2024 12.2
Freaking done.
White space code points are used to improve source text readability and to separate tokens, indivisible lexical units from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMA script white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 0.
This macro.
Feed. FF. FF. U plus FF. 0 width no break space.
Just so, I don't know. Maybe it'll be easier to find later.
Separator. USP. Note 1 U plus 0020. Space. And U plus 00.
But only do the utmost.
Code points are part of USP syntax. Note 2 other than for the code points listed.
It is up above.
ECMA script white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator. ZEDS 2.3 white space tab, VT, FF, ZWNBSP.
I know it's fine here.
Terminators, like white space code points. Line terminator code points are used to improve source text readability and to separate tokens units from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general,
Alright, so now,
occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminator,
this macro,
semicolon insertion, 12.10. A line terminator cannot occur within any
just glues the int to the end of it.
institution tail.
I don't know, it's done. Fucking done.
Within a string literal token except as part of a line continuation. A line terminator but cannot occur within a single line comment. Line terminators are included in the set of white space code points that
I just want to be done.
in regular expressions. ECMA International 2024-219. The ECMA script line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point
So now, I don't need this.
000A. Line feed. LF. LF. U plus 000.
Any of these. So instead of having to do this for the data and value properties,
And 29.
or method calls, whatever,
PS. Only the Unicode
I would have had to do this.
even are treated as line terminators. Other new line or line breaking Unicode code points are not
Then to
treated as white space if they meet the requirements listed in tab Le 36.
change this to like data,
LF is
change this to size.
terminator. It should be considered a single source character for the purpose of reporting line number.
Then scroll over to here.
Terminator. LF CRLSPS. Line terminator sequence. LF CR look ahead. LF LSPS CRLS.
Data.
Comments can be either single or multi-line. Multi-line comments cannot
Things like,
line comment
I don't know, it wasn't, whatever it was like this sort of,
terminator code point, and because of the general rule that a token is always as long as possible, a single
it's something like that.
consists of all code points from the marker to the end.
Put this here.
However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and
Then later on,
put elements for the syntactic grammar.
in the code,
Very important, because it implies that the presence or absence of single line
if it is a type that has to support that method called whatever,
0. Comments behave like white space and are discarded except that
I would have had to
contains a line terminator code
take like this block, whatever,
considered to be a line
do if define,
housing by the syntactic grammar. Syntax, comment, multi-line comment, single ECMA
check for data, see if that was defined,
line comment,
then check for the size, see if that's defined,
multi-line not asterisk char multi-line comment char sopt, post asterisk,
and then inside,
post asterisk comment chars, capital M U L T
I don't know, clearly I gotta like rename it,
E capital N
and there's no macro for this part, because this is like the main part,
W A R D
so we change this to whatever to like data,
S
or size, whatever it is,
O R capital A S
this one's size, so like size,
multi-line comment char sopt post
then data,
char sopt multi-line not asterisk char source character but not capital M U L T I capital L I N E capital O T
so I don't have to do that.
O R W A R D capital S L
It only took like 2 hours, only 2 hours.
A S T E source character but not one of
So instead of this,
single line comment char sopt single line comment chars single line comment char single line comment char sopt single line
all I need is this.
source character but not line terminator. A number of productions in this section are given alternative definitions in section B and 12.5 hashbang comments. Hashband comments are location sensitive and, like other types of comments, are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashband comment. Single line.
Like,
2.6.
I don't know. Way better. This is way better.
Name. Private identifier.
So now I can make the vector type
Plate. Note the div punctuator.
and quickly add properties.
Right brace
And then simply
template substitution tail productions derive additional
test the existence.
production. ECMA International 2024 221. 12.7 names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard and X number 31.
I like set up the type. If it doesn't exist, I define it
Word is an enumerator.
up here, and then I like
The syntactic grammar
rename a couple spots. And I don't know, yeah.
word. The Unicode identifier grammar is based on character
I'm almost done.
by the Unicode
All I
Standard.
have to do now is glue
In the spec
this
in the latest version of the Unicode Standard must be
to the beginning of this
forming ECMA script implementations. Each
and take a number.
implementations may recognize
So each of them will have its own bank or whatever bears.
syntax, private identifier, identifier name, identifier start, identifier name, identifier.
And then I can finally freaking set up a vector class. The fake class is not really a class, but it'll like emulate or simulate or whatever. It'll do the same thing as C++ does.
Underscore identifier
Both have C++.
code ID
And then I'll like set up I'll call malloc,
one of
the function that like everyone's scared to call
D E
because they use vectors in the first place
J
in C++. Because malloc is like so scary.
Q R
And I'll like show like how scary malloc is. It's just so scary.
Y
Real scary to use malloc.
capital B
Super scary.
capital D not Christavixes Unicode ID start any
I can't believe people are like scared to use malloc.
Unicode ID continue any Unicode code point with the Unicode property
It's like, what even?
the non-terminal Unicode escape sequence is given
So the next logical thing is like use C++ vectors or C++ vector.
point addition
Only makes sense.
0024 dollar sign and U plus 005F low line are permitted anywhere in an identifier name and the code points U plus 200C 0 with non-joiner and U plus 200D 0 with joiner are permitted anywhere after the first code point of an identifier name. 22 copyright sign ECMA International 2024. Note to the non-terminal identifier part derives via Unicode ID continue. 2. 7. 1 identifier names. Unicode escape sequences are permitted in an identifier name where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape
So then finally, delete these.
point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were
If it doesn't run, I'd be really annoyed.
the result
Is this possible? That like rename stuff
exact same sequence of source character
and like miss the fact that it's not calling correctly?
elements of identifier name
So now I guess I'll find out.
are based upon
Hopefully, it's good.
regardless of whether or not an escape
And
contribute any particular code point.
run.
Find names that are canonically equivalent according to the Unicode standard and not
Okay, it's good.
placement of each a Unicode escape sequence. They are represented by the
I guess water.
sequence of code points. 2, 7, 1, 1 static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of the Unicode escape sequence is not some Unicode code point, matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of the Unicode escape sequence is not some Unicode code, e point matched by the identifier part char lexical grammar production. 2, 7, 1, 2 static semantics. Identifier code points. The syntax-directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions: identifier name, identifier start. Let CP be identifier code point of identifier start. Return CP, identifier name, identifier name, identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2, 7, 1, 3. Static semantics. Identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions: identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the MV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the MV of code point. 2, 7. 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed width font, in some syntactic production. The keywords of ECMA script include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts. If and while a reserved word's await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names: those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield. Those that are contextually allowed as identifiers, namely await and yield. Those that are contextually disallowed as identifiers, in strict mode code, let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meter, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax: reserved word. 1 of await break case catch class const continue debugger default delete do else enum export extends false finally for function if import an instantia new null return super switch this throw true try type off bar void while with yield. 24. ECMA International 2024. Note 1 per 5. 1. 5. Keywords in the grammar match literal sequences of specific source character elements. A code point in a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3. 1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3
I'm so tired of this.
words, but they are
The GPU programming has nothing even to do with the GPU.
1,
It's like C program
1, 5,
and keeping track of things separate from the GPU.
1, 1,
Because the GPU is like this isolated, super special piece of hardware
0.8 punctuator,
where like you interact with it through opaque pointers.
optional chaining punctuator,
Like, for fuck's sake.
1 of, comma, equals.
I hate this.
Equals plus percent plus plus
I got hiccups. What the hell?
percent equals
I haven't had hiccups in so long.
equals and equals div punctuator equals sign
I gotta focus.
2.9 literals 2 9 1 null literal syntax null literal null x
I don't want to be doing this.
225
I want to be freaking...
Boolean literal syntax Boolean literal true
whatever.
9 3 numeric literal syntax numeric literal separator numeric literal decimal big integer literal non-decimal integer literal plus sep non-decimal integer literal plus sep big int literal suffix legacy octal integer literal decimal big integer literal 0 big int literal suffix non-zero digit decimal digits plus sep up big int literal suffix non-zero digit numeric literal separator decimal digits plus sep big int literal suffix non-decimal integer literal sep binary integer literal sep octal integer literal sep hex integer literal sep big int literal suffix n decimal integer literal decimal digits plus sep opt exponent part plus sep opt decimal digits plus sep exponent part plus sep opt decimal integer literal exponent part plus sep opt decimal integer literal 0 non-zero digit numeric literal separator opt decimal digits plus sep non-octal decimal integer literal decimal digits sep decimal digit sep decimal digit plus sep decimal digits plus sep numeric literal separator decimal digit 1 of 0 1 2 3 4 5 6 7 8 9 26 ECMA International 2024 non-zero digit 1 of 123,456,789 exponent part sep exponent indicator signed integer sep exponent indicator 1 of VE signed integer sep decimal digit sep decimal digit sep decimal digit sep binary integer literal sep 0b binary digit sep 0b binary digit sep binary digits sep binary digit sep binary digit plus sep binary digits plus sep numeric literal separated binary digit 1 of 0 1 octal integer literal sep 0 octal digit sep 0 octal digit sep octal digits sep octal digit sep octal digit plus sep octal digits plus sep numeric literal separator octal digit legacy octal integer literal 0 octal digit legacy octal integer literal octal digit non-octal decimal integer literal 0 non-octal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal digit non-octal decimal integer literal decimal digit capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L 0 octal digit capital L E G A C Y capital O C T A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89. ECMA International 2024 227. Hex integer literal, SEP. 0x hex digit SEP. 0x hex digit SEP. Hex digits, SEP. Hex digit SEP. Hex digit plus SEP. Hex digits plus SEP. Numeric literal separator hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics. Early errors. Numeric literal, legacy octal integer literal decimal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy. 2, 9, 3, 2 static semantics. MV. A numeric literal stands for a value of the number type or the begin type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of DC mal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer, decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or of binary digit. 0 is 0, the MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the MV of decimal digit. 2 or of non-zero digit, the MV of decimal digit. 3 or of non-zero digit, the MV of decimal digit. 4 or of non-zero digit, the MV of decimal digit. 5 or of non-zero digit, the MV of decimal digit. 6 or of non-zero digit, the MV of decimal digit. 7 or of non-zero digit, the MV of decimal digit. 8 or of non-zero digit, the MV of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4. 5 or of hex digit. 5 or of octal digit. 5 is 5. 6 or of hex digit. 6 or of octal digit. 6 is 6. 7 or of hex digit. 7 or of octal digit. 7 is 7. 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit, or of hex digit. A is 10, the MV of hex digit. B or of hex digit. B is 11, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separated binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of octal digits. Octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit. The MV of non-octal decimal integer literal capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L non-octal digit is the MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L octal digit is the MV of capital L E G A C Y capital O C T A L capital L I K E capital D E C I M A L capital I N T E G E R capital L times 10 plus the MV of octal digit. The MV of hex digits. Hex digit is the MV of hex digit 16 plus the MV of hex digit. The MV of hex digits numeric literal separator hex digit is the MV of hex digit 16 plus the MV of hex digit 2 9 3 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a begint. It is defined piecewise over the following productions. Numeric literal, decimal literal, return round MV result. MV of decimal literal. Numeric literal, non-decimal integer literal, return. MV of non-decimal integer literal. Numeric literal, legacy octal integer literal, return. MV of legacy octal integer literal. Numeric literal, non-decimal integer literal begin literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit big int literal suffix 1. Return the big int value for the MV of non-zero digit. Decimal big integer literal, non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let MV be the MV of non-zero digit 10n plus the MV of decimal digits. Return Z, MV, 2, 9, 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus. U plus 000D, carriage return, and U plus 000A, line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit element S of the string. Syntax: string literal, double string character-sopt, single string character-sopt, double string characters, double string character, double string character-sopt, single string characters, single string character, single string character-sopt, double string character, source character but not one of or all line terminator. LS, escape sequence, line continuation, single string character, source character but not one of or all line terminator. LS, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit. Legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1, 2, 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1, ECMA International 2024 231. Note 2, LF and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000A. 2, 9, 4, 1 static semantics. Early errors. Escape sequence. Legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1: in non-strict code, this syntax is legacy. 2, 9, 4, 2 static semantics. SV, the syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below, or in 1293 3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters. Double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters. Single string character S is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or all line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0x2028. Line separator. The SV of double string character, PS, is the string value consisting of the code unit 0x2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or all line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0x2028. Line separator. The SV of single string character, PS, is the string value consisting of the code unit 0x2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0x0000. Null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to Table 38. Note 2. It is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error. Function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B0x0008. Backspace. BS. T0x0009. Character tabulation. HT. N0x00A. Line feed. LF, V0x000B, line tabulation, VT, F0x000C, form feed, FF, R0x000D, carriage return CR, double quote, 0x0022, quotation mark, apostrophe 0x0027, apostrophe, backslash 0x005C, reverse solidus, the SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the MV of legacy octal escape sequence. The SV of non-octal decimal escape sequence, 8 is the string value consisting of the code unit 0x0038, digit 8. The SV of non-octal decimal escape sequence, 9 is the string value consisting of the code unit 0x0039, digit 9. The SV of hex escape sequence, X hex digit is the string value consisting of the code unit whose numeric value is the MV of hex escape sequence. The SV of hex 4 digits, hex digit it hex digit is the string value consisting of the code unit whose numeric value is the MV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the MV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0x0000, null 1 2, 9, 4. 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7. The MV of hex escape sequence, X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits, hex digit is 0x1000 the MV of the first hex digit, plus 0x100 the MV of the second hex digit plus 0x10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2.2.2.1. An implementation may extend the ECMA script regular expression grammar defined in 2.2.2.1. But it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char. Regular expression non-terminated but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Regular expression class, regular expression char, regular expression non-terminated but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Regular expression class, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Regular expression non-terminator, regular expression non-terminator. Source character but not line terminator, regular expression class chars, regular expression class chars. Empty, regular expression class chars, regular expression class char. R, regular expression class char, regular expression non-terminated but not one of or. Capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. 2 regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the 2 literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. See 2.2.2 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify a part char. 2. 9. 5. 1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1 2 9 5 2 static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1 2 9 6 template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note: 2 regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use comma dot. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $, or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit. Decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead, not code point. Hex digits. SEP. But only if MV of hex digits. 0x10ff. Code point. Hex digits. SEP. But only if MV of hex digits 0x10ff. Note: template substitution tail is used by the input element template tail alternative lexical goal 1 2 9 6 1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code unit, S, of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $, is the string value consisting of the code unit 0x0024, $. The TV of template character, template escape sequence is the SV of template escape sequence. The TV of template character, not escape sequence is undefined. The TV of template character, line terminator sequence is the TRV of line terminator sequence. 236. Copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequence is the empty string 1 2 9 6 2 static semantics. TRV, the syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $, is the empty string. The TRV of template middle, $, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $, is the string value consisting of the code unit 0x0024, $. The TRV of template character, template escape sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence. 0 is the string value consisting of the code unit 0x0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0x0030, digit 0, and the TRV of decimal digit, the TRV of not escape sequence, x, look ahead hex digit, is the string value consisting of the code unit 0x0078, Latin small letter x, the TRV of not escape sequence, x hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0078, Latin small letter x, and the TRV of hex digit, the TRV of not escape sequence, u, look ahead hex digit, look ahead, is the string value consisting of the code unit 0x0075, Latin small letter u, the TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, and the TRV of hex digit, the TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of not escape sequence, u hex digit, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit, the TRV of not escape sequence, u, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, and the code unit 0x007b, left curly bracket, the TRV of not escape sequence, u, not code point, look ahead hex digit, is the string concatenation of the code unit 0x0075, Latin small letter u, the code unit 0x007b, left curly bracket, and the TRV of not code point, the TRV of not escape sequence, u, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0x0075, Latin small letter u, the code unit 0x007b, left curly bracket, and the TRV of code point, the TRV of decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence, non-escape character is the SV of non-escape character. The TRV of single escape character, 1 of BFNRTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence, X hex digit is the string concatenation of the code unit 0x0078, Latin small letter x, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence U hex 4 digits is the string concatenation of the code unit 0x0075, Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence U code point is the string concatenation of the code unit 0x0075, Latin small letter u. The code unit 0x007b, left CU RLY bracket, the TRV of ECMA International 2024-237 code point, and the code unit 0x007d, right curly bracket, the TRV of hex 4 digits, hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 A B C D E F A B C D E F is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation line terminator sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of line terminator sequence, the TRV of line terminator sequence, LF, is the string value consisting of the code unit 0x000A line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0x000A line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0x2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0x2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0x000A line feed. 2.10 Automatic semicolon insertion. Most DCMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.1.0.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is parsed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be parsed as the terminating semicolon of a do-while statement. 1.4.7.2 When, as the source text is parsed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is parsed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence. 38 ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted auto. If the semicolon would then be parsed as an empty statement, or if that semicolon would become one of the two semicolons in the header of a for statement. C14.7. 4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression, yield, await. No line terminator here. Plus plus left-hand side expression, yield, await. No line terminator here. Continue statement, yield, await. Continue, continue. No line terminator here. Label identifier, yield, await. Break statement, yield, await. Break, break. No line terminator here. Label identifier, yield, await. Return statement, yield, await. Return, return. No line terminator here. Expression, plus in yield, await. Throw statement, yield, await. Throw, no line terminator here. Expression, plus in yield, await. Yield expression, in, await. Yield, yield. No line terminator here. Assignment expression in, plus yield, await. Yield, no line terminator here. Assignment expression in, plus yield, await. Arrow function, in, yield, await. Arrow parameters, yield, await. No line terminator here. Equals. Concise body in, async function declaration, yield, await. Default, async, no line terminator here. Function binding identifier, yield, await. Formal parameters, yield, plus await. Async function body, plus default. Async, no line terminator here. Function, formal parameters, yield, plus await. Async function body, async function expression, async, no line terminator here. Function binding identifier, yield, plus await. Opt, formal parameters, yield, plus await. Async function body, async method, yield, await. Async, no line terminator here. Class element name, yield, await. Unique formal parameters, yield, plus await. Async function body, async generator declaration, yield, await. Default, async, no line terminator here. Function binding identifier, yield, await. Formal parameters, plus yield, plus await. Async generator body, plus default. Async, no line terminator here. Function, formal parameters, plus yield, plus await. Async generator body, async generator expression, async, no line terminator here. Function binding identifier, plus yield, plus await. Opt, formal parameters, plus yield, plus await. Async generator body, async generator method, yield, await. Async, no line terminator here. Class element name, yield, await. Unique formal parameters, plus yield, plus await. Async generator body, async arrow function, in, yield, await. Async, no line terminator here. Async arrow binding identifier, yield, no line terminator here. Equals. Async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield, await. No line terminator here. Equals. Async concise body in, ECMA International 2024 239. Async arrowhead, async, no line terminator here. Arrow formal parameters, yield, plus await. The practical effect of these restricted productions is as follows. When a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a semicolon is automatically inserted before the plus plus or token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter s are followed by a line terminator before it equals token, a semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, A semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is, a postfix or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter, s, and its equals, should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2. 1, 0. 2 examples of automatic semicolon insertion. This section is non-normative. The source, 12. 3, is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source, 1, 2, 3, is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMA script sentence. The source, 4, A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insert because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, a plus b, is transformed by automatic semicolon insertion into the following return, a plus b. The source, a equals b plus c, is transformed by automatic semicolon insertion into the following a equals b plus c. The source, if b else c equals d, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be parsed as an empty statement. The source, equals b plus c, d plus c print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call, equals b plus c, d plus c print, in the circumstance that an assignment statement must begin with a left parenthesis. It is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2. 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus. ECMA International 2024-241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2. 1, 0. 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as proper high access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tagged template. The 13th of March 2011, with the previous expression as the member expression, unary plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3, two cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here, in this version of ECMA script. 2, 1, 0, 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions. 15.8, with relation to function definitions. 15.2, 42, ECMA International 2024, 13 ECMA script language. Expressions. 3.1 Identifiers syntax. Identifier reference. Yield, await. Identifier. Yield, yield, await, await. Binding identifier. Yield, await. Identifier. Yield, await. Label identifier. Yield, await. Identifier. Yield, yield, await, await. Identifier. Identifier name but not reserved word. 3, 1. 1 Static semantics. Early errors. Binding identifier. Identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and a string value of identifier is either arguments or eval. Identifier reference. Yield binding identifier. Yield label identifier. Yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference. Await binding identifier. Await label identifier. Await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier. Yield. Await. Yield. It is a syntax error if this production has a yield parameter. Binding identifier. Yield. Await. Await. ECMA International 2024 243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below, to prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter. Identifier reference. Yield, await. Identifier binding identifier. Yield, await. Identifier label identifier. Yield, await. Identifier. It is a syntax error if this production has a yield parameter and string value of identifier is y. Yield. It is a syntax error if this production has an await parameter and string value of identifier is await. Identifier. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3, 1, 2 Static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions. Identifier name. Identifier start. Identifier name. Identifier part. Let idtext unescaped be identifier code points of identifier name. Return code points to string. Idtext unescaped. Identifier reference. Yield binding identifier. Yield label identifier. Yield. Return yield. Identifier reference. Await binding identifier. Await label identifier. Await. Return await. Identifier. Identifier name but not reserved word. Return the string value of identifier name. private identifier. Identifier name. Return the string concatenation of 0x0023. Number sign. And the string value of identifier name, module export name, string literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024 131. 3 Runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression. Yield. Await. This. Identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Expression plus in yield await. Expression plus in yield await. Dart. Binding identifier yield await. Dart. Binding pattern yield await. Expression plus in yield await. Binding identifier yield await. Expression plus in yield await. Binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024 245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. The interpretation of capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N is refined using the following grammar. Parenthesized expression, yield, await, expression, plus in yield await. 3, 2, 1 Thetis keyword. 3, 2, 1. 1 Runtime semantics. Evaluation, primary expression, this, return. Resolve this binding. 3, 2. 2 Identifier reference. See 13.1 for identifier reference 1 3. 2, 3 literals. Syntax, literal, null literal, boolean literal, numeric literal, string literal. 3, 2, 3. 1 Runtime semantics. Evaluation, literal, null literal 1. Return null literal, boolean literal. If boolean literal is the token false, return false. If boolean literal is the token true, return true. Literal, numeric literal. Return the numeric value of numeric literal as defined in 1 2 9 3. Literal, string literal. Return the SV of string literal as defined in 1 2 9 4 2 46. ECMA International 2024 1 3 2 For array initializer, array elements may be elided at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await, elision opt, element list yield await, element list yield await, elision opt, element list, yield, await, elision not assignment expression, plus in yield await, elision not spread element yield await, element list yield await, elision not assignment expression, plus in yield await, element list yield await, elision not spread element yield await, elision, spread element, yield, await, dart, assignment expression, plus in yield await, 1 3, 2, 4, 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next index, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision: let len be next index plus 1. Perform. Set array length len true. Note: the above step throws if len exceeds 232. 1. Return len. Elision return array accumulation of elision with arguments array and next index plus 1 element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Let init result be evaluation of assignment expression. Let init value be get value init result. Perform create data property or throw array to string next index init value return next index plus 1. Note: an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2000.
Finally.
Element list.
Now,
Element. If elision is present, then a set next
I can copy paste this whole blob.
array and next index. Return array accumulation of spread element with arguments array and next index. Element list. Elision not assignment expression. Set next index to array accumulation of element list with arguments array and
In the entire type,
then
whatever you want to call it, template, is fully contained.
arguments array and next index. Evaluation of assignment value b get value init result.
This is so boring.
Array to string
At least I'm not using C++.
index plus 1 element list elision not spread element. Set next index to array accumulation of element list.
And I can like benchmark whatever after.
Elision is present.
It's probably not going to be faster
Index to
because C++ is going to cheat.
with arguments
The allocations are probably going to be on the stack.
array
If it can detect that it's in a function
element
and that it's not assigned to a global,
b evaluate
that it can optimize.
let spread objb
I would have to add so much extra stuff
ref let iterator record b
to account for that, and I couldn't just like
sync repeat let
easily test for that.
value
I'd have to like manually tag things with extra parameters
c perform
to guarantee like this is only ever on the stack, this is only this, only that.
next index next dset next index.
So I don't know.
Note
If I benchmark it and it ends up being faster,
properties are defined.
I'd be surprised.
The standard built-in array prototype object has been modified in a manner that would preclude the creating
So that's my plan,
3
or my goal. I'm gonna aim for getting done
times
to benchmark it.
evaluation array literal
Except I understand that it's not gonna be faster.
if elision is
So if it's not faster, I won't be surprised.
array
But if it is faster,
arguments array ands
I'll be surprised
return
because there's no way it should be faster.
element
Like C++
array create,
has been around for so long. There's no way
accumulate,
that a first attempt with a stupid macro system
return array, array literal, element
that avoids function calls that'd be faster.
b, array create, 0, let next index be, array accumulate,
Oh, this is so boring.
0, 48,
Alright, so
1024,
I could like,
elision is present, then a perform. Array accumul, Ashna elision with arguments array and next index, return array, 3,
I think it was here.
object initial,
Save it, run it back up, or run it, check it, save it back up.
definition list yield await, property definition list yield await, property definition list
Get some water.
wait, property definition yield await, property definition list yield await,
Go through, rename everything again,
property
re-update it,
yield await, identifier reference yield await,
and it should run.
name yield await, property name
It needs to run.
assignment expression plus
Because I don't want to be doing this.
definition yield await
I have a stupid JavaScript engine to write.
plus in yield await, property name
In this stupid shading program,
computer
shader program, GPU shader program,
name
has taken up
string literal numeric
way too much time.
property name yield await assignment
This is fucking C language.
await cover
I thought the GPU
await
would be more GPU programming,
initializer
not so much
wait in
dealing with things on C language side.
assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal.
Back up so I'm safe to mess it up.
Keys and associated values.
Which I probably should do. I should probably just go through and do it really quick.
The
If something gets messed up, I have it back up.
initializer is evaluated.
So like do like a first pass really fast,
2024 249.
knowing it might not work.
Contexts.
Planning to like undo and do it again. And the second time it would work.
For initialized name production is necessary to fully cover these secondary grammars. However,
I get some water.
production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5, 2 static semantics. is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a Boolean. It is defined piecewise over the following productions. Property name, literal property name, return false. Property name, computed property name, return true. Addition to describing an actual object initializer, the object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note to the list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3 static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5, 4 runtime semantics. Evaluation. Object literal. Return ordinary object create. Percent object prototype percent. Object literal. Property definition list. Property definition list. Let obj be ordinary object create. Percent object prototype percent. Perform. Property definition evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return. To string. NBR. Computed property name. Assignment expression. Let X per value be. Evaluation of assignment expression. Let prop name be. Get value. X per value. Return. To property key. Prop name. 3, 2, 5. 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition. Perform. Property definition evaluation of property definition list with argument object. Perform. Property definition evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let X per value be. Evaluation of assignment expression. Let from value be. Get value. X per value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let X per value be. Evaluation of identifier reference. Let prop value be. Get value. X per value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop p be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse, then a let is proto setter be false. Else if prop key is proto and is computed property key of property name is false, then a let is proto setter be true. Else a let is proto setter be false. If is anonymous function definition, assignment expression, is true and is proto setter is false, then a let prop value be. Named evaluation of assignment expression with argument prop key. Else a let X per value ref be. Evaluation of assignment expression. B let prop value be. Get value. X per value ref. If is proto setter is true, then a if prop value is an object or prop value is null, then I perform object. Prop value be return unused. Assert. Object is an ordinary, Extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop key. Prop value 0. Return unused. Property definition. Method definition. Perform. Method definition. Evaluation of method definition with arguments object and true. Return unused. 3, 2, 6. Function defining expressions. C15.2 for primary expression. Function expression. C15.5 for primary expression. Generator expression. C15.7 for primary expression. Class expression. C15.8 for primary expression. Async function expression. C15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7. Regular expression literal syntax. C12. 9. 5. 3. 2. 7. 1. Static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2. Static semantics. Capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a Boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, then A let string value be code points to string, pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern. Pattern text. U, V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3. Runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return. regexp create, pattern, flags. 3, 2, 8. Template literal syntax. Template literal, yield, await, tagged. No substitution template. Substitution template yield await tagged. Substitution template, yield, await, tagged. Template head expression, plus in yield await. Template spans yield await tagged. Template spans, yield, await, tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list. Yield, await, tagged. Template middle expression, plus in yield await. Template middle list yield await tagged. Template middle expression, plus in yield await. 3, 2, 8. 1. Static semantics. Early errors. Template literal, yield, await, tagged. No substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence, template literal, yield, await, tagged, substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument false is greater than or equal to 232. Substitution template, yield, await, tagged, template head expression, plus in yield await, template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence, template spans, yield, await, tagged, template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence, template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8. 2 static semantics. Template strings. The syntax-directed operation template strings takes argument raw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template, return template string, no substitution template, raw, substitution template, template head expression template spans, let head be template string, template head, raw, let tail be template strings of template spans with argument raw, return the list concatenation of head and tail, template spans, template tail, return template string, template tail, raw, template spans, template middle list template tail, let middle be template strings of template middle list with argument raw, let tail be template string, template tail, raw, return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle, raw, template middle list, template middle list template middle expression. Let front be template strings of template middle list with argument raw. Let last be template string, template middle, raw, return the list concatenation of front and last. 3, 2, 8. 3 static semantics. Template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called if or is true. Then, a let string be the TRV of template token, else, a let string be the TV of template token, return string. 3, 2, 8. 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called let realm be the current realm record. Let template registry be realm. For each element of template registry, do a if E is the same parse node as template literal, then I returnee. Let raw strings be template strings of template literal with argument true. Assert. Raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert. Count 232 1. Let template be array create, count 0. Let raw obj be array create, count 1. Let index be 0, 2. Repeat. While index, count. A let prop be to string, index. B let cook value be cook strings, index. C perform. Define property or throw, template, prop, property descriptor, cook value, writable, false, true, false. D let raw value be the string value raw strings, index. E perform. Define property or throw, raw, obj, prop, property descriptor, raw value, false, true, false. F set index to index plus 1. 3. Perform. Set integrity level, raw, obj, frozen. 4. Perform. Define property or throw, template, raw, property descriptor, raw, obj, false. Enumerable, false, false. 5. Perform. Set integrity level, template, frozen. 6. Append the record, template literal, template, to realm. 7. Return template. Note this apparity on returns undefined if or is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tagged template is evaluated. Where the template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMA script code. 1 3 2 8 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions: template spans, template tail, return a new empty list, template spans, template middle list, template tail, return, substitution evaluation of template middle list, template middle list, template middle expression, let subref be. Evaluation of expression, let sub be. Get value, subref, return sub, template middle list, template middle list, template middle expression, let preceding be. Substitution evaluation of template middle list, let next ref be. Evaluation of expression, let next be. Get value, next ref, return the list concatenation of preceding and next. 3 2 8 6. Runtime semantics. Evaluation, template literal, no substitution template, return the TV of no substitution template as defined in 1 2 9 6. Substitution template, template head expression, template spans, let head be the TV of template head as defined in 1 2 9 6. Let subref be. Evaluation of expression, let sub be. Get value, subref, let middle be. To string, sub, let tail be. Evaluation of template spans, return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Template spans, template tail, return the TV of template tail as defined in 1 2 9 6. Template spans, template middle list, template tail, let it be. Evaluation of template middle list, let tail be the TV of template tail as defined in 1 2 9 6. Return the string concatenation of head and tail. Template middle list, template middle expression, let head be the TV of template middle as defined in 1 2 9 6. Let subref be. Evaluation of expression, let sub be. Get value, subref, let middle be. To string, sub, return the string concatenation of head and middle. Template middle, list, template middle list, template middle expression, let rest be. Evaluation of template middle list, let middle be the TV of template middle as defined in 1 2 9 6. Let subref be. Evaluation of expression, let sub be. Get value, subref, let last be. To string, sub, return the string concatenation of rest, middle, and last. 3 2 9. The grouping operator.
So like at this point I like replace the old template with optional in UN32 whatever. Replace it with foo bars so it's not actually used now. And I like replace below to make sure it does work, so it does work or whatever. So now I gotta like copy paste this, rename the copy back to like optional uint32, and I have this as like the template to make the other ones. So now I can finally make the freaking vector stuff or whatever. Super exciting. So much fun. So I'm gonna do that. That took all day. And I'm pretty sure I can template the vector routine, but not like have to like template to the extreme. All I'd have to do is pass in the type and the size t, and then paste the single macro to call for all the vector types. So at least that'll be easy. It's the same exact routine, just different type. But I do have to like define the separate stupid thing for each thing. If C supported the macros being able to define macros, I can make a list. Well, then I need like a repeat macro. Well, either way, whatever. If that's possible, I wouldn't have to type all this. I shouldn't have to type all this. C language sucks in the first place. Macros are just like a replacement for what C is lacking, and the replacement for what the compiler's lacking is dependent on the OS, which also lacks, because it's a whole shit show from the bottom of the chain on the web. From the bottom of the chain all the way to the top, whatever. Like the weakest link is the operating system itself. Piece of shit. Save backup and then whatever. I don't know. There's no point in explaining malloc. I'm literally just gonna call malloc and then free it. It's not that complicated. There's no point in explaining it. It's literally, I don't know, the simplest thing ever. So I'm gonna try to like copy paste this blob, make the type, and then replace C++ and get this stuff running. It's not that much stuff to do. I gotta find some really loud music too. Try to focus. So boring though. This is like really boring.
has binding, n. The has binding concrete method of a global environment record env-rec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called let dcl-rec be env-rec. If dcl-rec has binding, n, is true, return true. Let obj-rec be env-rec. Return obj-rec has binding, n, 1, 1, 4, 2 create mutable binding, n, d. The create mutable binding concrete method of a global environment record env-rec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the num n that is uninitialized. The binding is created in the associated 44 copyright sign, ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called let dcl-rec be env-rec. If dcl-rec has binding, n, is true, throw a type error exception. Return dcl-rec create mutable binding, n, d, 1, 1, 4, 3 create a mutable binding, n, s. The create immutable binding concrete method of a global environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the num n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called let dcl-rec be env-rec. If dcl-rec has binding, n, is true, throw a type error exception. Return dcl-rec create a mutable binding, n, s, 1, 1, 4, for initialize binding, n, v. The initialize binding concrete method of a global environment record env-rec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called let dcl-rec be env-rec. If dcl-rec has binding, n, is true, then a return dcl-rec initialize binding, n, v. Assert. If the binding exists, it must be in the object environment record. Let obj-rec be env-rec. Return obj-rec initialize binding, n, v, 1, 1, 4, 5 set mutable binding, n, v, s. The set mutable binding concrete method of a global environment record env-rec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change th, e bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let dcl-rec be env-rec. If dcl-rec has binding, n, is true, then a. Return dcl-rec set mutable binding, n, v, s. Let obj-rec be env-rec. Return obj-rec set mutable binding, n, v, s, 1, 1, 4, 6 get binding value, n, s. The get binding value concrete method of a global environment record env-rec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw
I'm asking chatbot
identifier
what it assumes the routine looks like for
exception. A property name then normally
the C++ vector class.
currently right.
I'll just copy paste that and then modify it.
The following steps when called let dcl-rec be env-rec. If dcl-rec has binding, n, is true, throw a type error exception. Return dcl-rec create mutable binding, n, v, s. The set mutable binding concrete method of a global environment record env-rec takes arguments n, a string, and v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change th, e bound value of the current binding of the identifier whose name is n to the value v if the binding is an immutable binding and s is true. A type error is thrown. A property name then normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called let dcl-rec be env-rec. If dcl-rec has binding, n, is true, then a return dcl-rec initialize binding, n, v, assert. If the binding exists, it must be in the object environment record. Let
Give me some time.
DCL rec has binding. N is
At least Chatbot can do that,
DCL rec get binding.
like, correctly. It can't do anything else, but it can do the simple things.
145.
Chatbot sucks,
JREC BENV rec. Return. OBJ rec get binding.
but this time, for the first time, in like thousands of questions to Chatbot, it'll actually give me something that'll save me time.
BNV rec takes argument.
For the first time, out of way too many times.
Normal completion.
So, Chatbot still blows. Microsofties.
Explicitly designated as being subject to deletion. It performs the following steps when called let DCL rec BENV rec. If DCL rec has binding, N is true, then A return. DCL rec delete binding, N let OBJ rec BENV rec. Let global object be OBJ rec. Let existing prop be has own property, global object, N if existing prop is true, then A let status be OBJ rec delete binding, N B if status is true and ENV rec contains N, then I remove N from ENV rec C return status, return true, 1, 1, 4. 8 has this binding, the has this binding concrete method of a global environment record ENV rec takes no arguments and returns true. It performs the following steps when called return true, 1, 1, 4. 9 has super binding, the has super binding concrete method of a global environment record ENV rec takes no arguments and returns false. It performs the following steps when called return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record ENV rec takes no arguments and returns undefined. It performs the following steps when called return undefined 9, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record ENV rec takes no arguments and returns a normal complete.
Alright, see if Chatbot will save me time.
Steps when called return ENV rec 140.
I'm really hoping it'll save me time. Last time, it actually gave a useful answer.
Global environment records do not provide.
So hopefully this time, it'll be useful.
1
I'm so tired of programming in C language.
of a global environment
I want to get this fucking engine done
and return
so I can release some real shit.
identifier has a binding in this record that was
Because everything is shit.
or a function
I'm so tired of shit.
performs the following steps when
But for now, I gotta play this shit. This is all the shit you get. So I gotta make the shit out of it.
false, 1, 1, 4
And I got the shit.
N the has lex
I'm so tired of this shit.
method of
It's just shit.
record ENV rec takes argument in
Like, for shit's sake.
it determines if the argument identifier has a binding in this record that was
Oh, this is a big old turd.
such as a lexical declaration or a class declaration. It performs the following steps when called let DCL rec BENV rec.
Oh, it doesn't even give me the fucking routine.
N, 1, 4, 1, 4 has restricted global property. N, the has restricted global property concrete method of a global environment record ENV rec takes argument in a string and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is the name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called let OBJ rec BENV rec. Let global object be OBJ rec. Let existing prop be global object. N if existing prop is undefined. Return false. If existing prop is true. Return false. Return true, 1, 1.
I think there's something called like pushback or something.
N the
Yeah, pushback.
method of a global environment record ENV rec takes argument in a string and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if called for the same argument in redundant var declarations and var declarations. Global object properties are allowed. It performs the following steps when called let objrec be envrec, let global object be objrec, let has property.
So we need pushback,
Global object
size, data,
is true.
release. I think that's it. That's probably all there is, I think.
Global object. Note properties may exist.
But there might be like a begin and end. They could begin and then end one. So I don't know.
Global binding may not be created.
This should cover it.
Configurable property of the global object.
Come on, chip out. Give me something useful.
Property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function n. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called let objrec be envrec, let global object be objrec, let existing prop be global object n. If existing prop is undefined, return is extensible global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values, true, enumerable, true, return false, 1, 1, 4, 1, 7 create global var binding, n, d, the create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called let objrec be envrec, let global object be objrec, let has property b, has own property, global object, n, let extensible b, is extensible, global object. If has property is false and extensible is true, then a perform objrec create mutable binding, n, d, b perform objrec initialize binding, n, undefined. If envrec does not contain n, then a append enter envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding, n, v, d, the create global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMA script language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called let objrec be envrec, let global object be objrec, let existing prop be global object, n. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor, v, true, true, d, else, a let desc be the property descriptor, v, perform. Define property or throw, global object, n, desc, perform. Set, global object, n, v, false. If envrec does not contain n, then a append enter envrec. Return unused, 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMA script module. In addition to normal mutable and immutable bindings, Module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for getBindingValue. Delete binding has this binding and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms. 1, 1, 5, 1 getBindingValue, n, s. The getBindingValue concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language, a value, or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called: assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n to be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env getBindingValue. N2 true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note S will always be true because a module is always strict mode. Code 9, 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method purpose: create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding, return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note: module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C13, 5, 1, 1, 1, 1, 5, 3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called: return true, 1, 1, 5, 4 get this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called: return undefined, 1, 1, 5, 5 create import binding, n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called: assert. envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding, and record that the binding is initialized. Return unused, 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9, 1, 2, 1 get identifier reference, env, name, strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called: if env is null, then a return the reference record. unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024. Note, module environment records always provided this binding. AB, let outer be env. Return, get identifier reference, outer, name, strict. 9. 1. 2. To new declarative environment, E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment, O, W, E. The abstract opera T on new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O. Set env to W. Set env to E. Return env, 1, 2, 4 new function environment, F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment, G. This value, the abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec be new object environment, G, false, null. Let dclrec be new declarative environment, null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment, E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env. ECMA International 2024 151 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names. A list of private names. The private names declared by this class. 9. 2. 1 private environment record operations. The following abstract CT operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env. Names, 2, 1. To resolve private identifier. Privy env. Identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier. a string, and returns a private name. It performs the following steps when called. Let names be privy and v. For each private name Pn of names, do a if Pn is identifier. Then, I return Pn. Let outer privy and v be privy and v. Assert. Outer privy and v is not null. Return resolve private identifier. Outer privy and v. Identifier. Point 3 realms. Before it is evaluated, all ECMA script code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24. Realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal parse node, and v, an array, f. The agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1.8. Note 1: in realm records is only used when running an import expression in a context where there is no active script for module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec, set realm rec to agent signifier, set realm rec to undefined, set realm rec to undefined, set realm rec to a new empty list, return realm rec, ECMA International 2024 153, 9.3. 2. Create intrinsics. Realm rec, the abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in Table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform. Capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global obj, this value, the abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global OBJ is undefined, then A. Let intrinsics be realm rec. B. Set global OBJ to ordinary object create intrinsics. Assert global OBJ is an object. If this value is undefined, set this value to global OBJ. Set realm rec to global OBJ. Let new global env be new global environment. Global OBJ. This value, set realm rec to new global env. Return unused, 3.4 set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec. For each property of the global object specified in clause 19, do A. Let name be the string value of the property name. B. Let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. C. Perform. Define property or throw. Global. Name. Desc. Return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources, script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in, first-out manner. However, some ECMA script features require non-LIFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment identifies the environment record that holds bindings created by variable statements within this execution context. Private environment identifies the private environment record that holds private names created by class elements in the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27, ECMA International 2024-155. Table 27, additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding, name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If envi is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code: let strict be true, else let strict be false. Return: get identifier reference, env, name, strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment too. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion contained on an ECMA script language a value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Return envrec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let envrec beget this environment. Assert envrec has a field. Return envrec. 4.6 Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm, jobs and host operations to enquire jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enquire generic job. Capital H O S T capital E N Q U
So I got
capital F I N
not everything in place.
L I Z A T I O N
All I need to do is
G I S T R host enquire promise job and host enquire timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations
data size and
time
pushback.
in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform after which the execution only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before
I can't stand
job starts.
the double clicking,
The abstract
the double triggering,
completion, implement.
freaking keyboard and mouse.
ECMA International 2024-157. Note 1 host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority at any particular time. Script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record. Let EC be the
So I take this whatever.
text under execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to
And then template it up.
a script code if all of the following conditions are true. The execution context stack is
So 1,
the realm component of execution context
3,
stack is a realm record. Particular kind
looking for this.
performance requirements, 5.1 job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are
Control H,
included by the host may have additional
paste.
to propagate the state. Job abstract closure
Guess pushback first.
function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in
Find this after.
table 28. Job
It's first size.
5.2 host make job callback. Callback.
Place all.
Abstract operation host make job callback takes argument callback. A function
I need this too.
a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record D whose field is callback. Note to host environment.
Data.
Evaluate code by pushing execution.
Control H,
Execution
paste. Place all.
specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked.
Control H, paste. Place all.
Job, like a promise handler, is invoked. The invocation pushes its own execution context and realm. Note the WHATWGHTML specification, https://html.spec.whatwg.org. For example, Uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object. The function to invoke when the job is invoked. Host-defined.
And paste.
Is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host.
But I had to delete it.
The following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implement.
Now paste.
Job callback, 5.3 host call job callback.
I just put these in a block.
B. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback. A job callback record. V. An ECMA script language value, and arguments list. A list of ECMA script language values. And returns either a normal completion containing an ECMA script language value or a throw.
What is it? Member routine?
All job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 5 host enqueue promise job. Job. Realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some.
Why is it grayed out?
The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled. D with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform.
Yes, garbage.
Steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module beget active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function.
Okay, now issue correctly.
Scheduled
Catch that these aren't defined. I throw an error.
action. Calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling.
Because I don't know. I set it up like that, whatever. So like if something's not defined, it'll catch it. They had it.
Specification. ECMA International
So build.
159. Note the realm for job.
Then I call it.
Resolved enable job is usually the result of calling get function realm on the.
All three of them.
The realm for jobs returned by
So now I define the global define.
function realm on the hand.
That's concatenated to the unique. Whatever.
Realm is null. For
Token to identify whatever type it is and shit.
that is called on a revoked proxy. Realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example error objects, will be created. The WHATW
And define these here.
specification https://html.spec.whatwg.org. For example, uses realm to check for the ability to run script and for the entry https://html.spec .whatwg.org entry. Concept, 5.6 host enqueue timeout job. Timeout job. Realm. Milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job. A job abstract closure. Realm. A realm record. And milliseconds. A non-negative finite number. And returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host defined realm. The abstract operation initialize host defined realm takes no arguments and
So now it shouldn't throw an error.
Unused or a throw completion. It performs the following steps when called. Let realm be created.
And the old call still works.
Execution context. Set the function of new context to null. Set the realm of new context to realm. Set the scripto module of new context to null. Push new context onto the execution.
So now all I gotta do
Context is now the running execution context.
is get size, data, pushback,
Serve as realm's global object. Let
routines, whatever defined.
created in a host-defined manner. Otherwise, let global be undefined.
Chatbot gave me
Should be created as the global object.
vector pushback.
As that this binding in realm's global scope return an object other than the global object. Let this value be such an object created in a host-defined manner. Otherwise, let this value
So size and
indicating that realm's global this binding should be the global object. Perform set realm global object. Realm global
data.
0. Let
Those are easy.
set default global
Well, pushback is easy too.
1. Create any host-defined global object properties on global obj. 2. Return unused. 0.7 agents. An agent comprise is a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an
So I'm literally almost done.
executing thread, the constituent
Way better than C++ template.
agent. An agent's executing thread executes algorithmic steps on the agent's execute
And some water.
independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithms get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block, a boolean, determines whether the agent can block or not. Signifier, an agent signifier, uniquely identifies the agent within its agent cluster. Is lock-free 1, a boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2, a boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8, a boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kep al iv, a list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a Boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR. Agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs with indifferent agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note to the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any Windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information to identify the agent that was terminated, each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waiter list record. Prior to any evaluation of any ECMA script code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose and fields are emptyly STS. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents when for agent resource accounting indicates that the agent is run away. Note 6 all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7 an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. Point 9 forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10 processing model of weak ref and finalization registry targets 9.10. 1 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on 2 operations which happen at particular points in time. When weak ref prototype derif is called, the referent, if undefined is not returned, is kept alive so that subsequent, synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with a finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made, after synchronous ECMA script execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMA script execution. Because hosts may assemble longer, synchronous ECMA script execution runs. This specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMA script implementations include garbage collector implementations which run in the background, including when ECMA script is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMA script execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 liveness. For some set of objects and/or symbols, a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref derif of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sexEST writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture 2 notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, A set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024, there exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4: the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5: presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the and fields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6: liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway, 10.3 execution. At any time, if a set of objects and or symbols S is not live, an ECMA script implementation may perform the following steps atomically. For each element value of S, do A for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each weak map such that map contains a record R such that R value. Do I set R. 2. Set R to empty. D for each weak set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value V without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of V, 10.4 host hooks, 10, 4, 1, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R. Finalization registry, the host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion, cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMA script implementations are expected to call clear-kept objects when a synchronous sequence of ECMA script executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12 Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry has and internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A. Choose any such cell. B. Remove cell from finalization registry. C. Perform host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weakly. V. The abstract operation can be held weakly takes argument V, an ECMA script language value, and returns a Boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined. Return true. Return false. Note when the abstract operation add to kept objects is called with a target object or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak. Memory resources in implementations. 0 ordinary and exotic objects behaviors. 0.1 ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for getAccess, making it behave as if P was a property of O. If P refers to a writable data property on the ECMA International 2024-167 object, setAccess of P on O creates a new data property named P on O. If P refers to a non-writable data property on the object, setAccess of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both getAccess and setAccess. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility-related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMA script language value, and desc is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called return ordinary get prototype of O10, 1, 1, 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called return O10, 1, 2, V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a Boolean. It performs the following steps when called return ordinary set prototype of O, V10, 1, 2, 1 ordinary set prototype of O, V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a Boolean. It performs the following steps when called let current be O if same value E, V, current, is true. Return true. Let extensible be O if extensible is false. Return false. Let bev. Let done be false. Repeat. While done is false. A if P is null, then I set done to true. B else if same value P, O, is true, then I return false. C else. I if P is not the ordinary object internal method defined in 1, 0, 1, 1, set done to true. 2. Else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for AND 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a Boolean. It performs the following steps when called return ordinary is extensible. O10, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a Boolean. It performs the following steps when called return O10, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called return ordinary prevent extensions. O10, 1, 4, 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called set O to false, return true. 0, 1, 5, P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called return ordinary get own property O, P10, 1, 5, 1 ordinary get own property O, P. The abstract operation ordinary get own property takes arguments O, an object, and p, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key p, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is p. If X is a data property, then A set D to the value of X's attribute, B set D to the value of X's attribute, else A assert X is an accessor property, B set D attribute, C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute, set D to the value of X's attribute, return D 0, 1, 6, P. Desk. The internal method of an ordiner, Y object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define own property O P desk 1 0 1 6 1 ordinary define own property O P desk. The abstract operation ordinary define own property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O, P. Let extensible be is extensible O, return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1 0, 1, 6, 3, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, O, P, extensible, desk, current. The abstract operation, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, P, E, S.
So all I gotta do then is
O, and
get the routines in place.
a property key, extensible, a boolean, desk,
I want to block, unwrap these blocks.
a property descriptor or undefined, and returns a boolean. It returns true if and
So we're gonna make sure the other ones are the same.
with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert is property key, P, is true if current is undefined. Then
And then
return false. B if O,
I think I want to do like one tweak.
B if is accessor descriptor.
I think I'll allocate 4 times the size
Property named P
of whatever the type is
and attributes are set to the value of the corresponding
in the vector.
desk has that field, or to the attribute's default value otherwise. D else I create a known data property name. Oh, whose
and then I like write to that, to those four whatever,
responding field in desk if desk
and then commit the change only when data is called to like read from it.
current is a fully populated property descriptor. If desk does not have any fields, return true. If current
So that
70
I get like the benefit of the first couple calls not needing
is a field and
to resize,
return false.
and there may be some kind of like small difference
Return false. If is
or improvement with caching
desk is false,
if I like write to the same spot, the same four spots over and over and over,
current return false.
and then not write back
Current is true.
until I have to, but then it also does have to end up
2
writing back in between.
else if current
But if you can do like four writes
desk has a field
instead of just one,
true, return false. 2 if desk has a field
after resizes,
desk
it might give it like,
return false
I don't know, I'm just trying anyways.
undefined. Then a if is data descriptor, current is true and is accessor descriptor.
Or I should just like not do anything funky
Let
and get it running. I might do that first.
configurable be current. 2 if desk has a field, let enumerable be desk, else let enumerable be current. 3 replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the
It'll probably be slower than
or to the attribute's default value otherwise.
C++.
The descriptor, current, is true and is data descriptor, desk.
So I shouldn't like attempt to optimize it.
Let
There's no reason.
else let configurable be
It's just like a one-off program.
desk has a field, let enumerable be desk, else let enumerable be current.
But it'd be fun too.
The property named P
So I gotta focus and get this done.
whose and enumerable,
This is so boring.
configurable and enumerable, respectively, and whose and attributes are set.
Why is it
Responding field in desk if desk has that
wrapping it as false?
as see else. I for each field of desk. Set
What the heck? That's so annoying.
the property named P of object O to the value of the field
They're both false.
turn true. 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7. 1 ordinary has property O, P. The abstract operation ordinary has property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own B.
Let's add the block.
And is not
I think I went it out.
turn true. Let parent be. O, if parent is not null, then a return parent, P5. Return false. 0, 1, 8. The arguments P, a property key, and receiver, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw.
So at least that'll be like indented.
Following steps when called return, ordinary get, O, P, receiver, ECMA International 2024 171, 10, 1, 8, 1 ordinary get, O, P, receiver. The abstract operation ordinary get takes arguments O, an object, P, a property key, and receiver, an ECMA.
It will not freaking clipboard.
A normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let desk be. O, P. If desk is undefined, then a let parent be. O, B. If parent is null, return undefined. C. Return parent. If is data descriptor, desk, is true. Return desk, assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return, call, getter, receiver, 0, 1, 9. The return, ordinary set, O, P, V, receiver 1, 0, 1, 9. 1 ordinary set, O, P, V, receiver. The abstract operation ordinary set takes arguments O, an object, P, a property key, V, an ECMA script language value, and receiver, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called let ownDesc be O, P, return, ordinary set with own descriptor, O, P, V, receiver, ownDesc, 0, 1, 9, 2 ordinary set with own descriptor, O, P, V, receiver, ownDesc. The abstract operation ordinary set with own descriptor.
Seem really backup just because
Object, P,
you never have too many backups.
V, an ECMA script language value, receiver, an ECMA script language value, and ownDesc, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if ownDesc is undefined, then I let parent be O, B. If parent is not null, then I return parent. I set ownDesc to the property descriptor, undefined, true, true, true. If is data descriptor, ownDesc, is true, then 72 ECMA International 2024 ABCDE. If ownDesc is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver, P. If existing descriptor is not undefined, then I. If is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor
As Jetbot says, it needs to look like this.
B. Let value desc be the property descriptor, V. I've return receiver, P. Value desc, else I assert receiver does not currently have a property P. 2. Return create data property, receiver, P, V, assert, is accessor descriptor, ownDesc, is true. Let setter be ownDesc. If setter is undefined, return false. Perform call setter, receiver, V, return true. 0, 1, 1, 0, P. The internal method of an ordinary object O takes argument P, a property key, and return
I'm pretty sure the malloc
or a throw completion. It performs
should be aligned
called return ordinary
to some like
P10 1 1 0 1 ordinary delete
amount, whatever. Probably like
abstract operation ordinary delete takes arguments of
64 bytes.
and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called let desc be O, P. If desc is undefined, return true. If desc is true, then A. Remove the own property with name P from O. B. Return true. Return false. 0, 1, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called return ordinary own property keys. O10, 1, 1, 1, 1 ordinary own property keys. O, the abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called let keys be a new empty list for each own property key P of O such that P is an array index in ascending numeric index order. Do A append P to keys for each own property key P of O such that P is a string
So 64 bytes.
index in ascending chronological order of property creation. Do I append P to keys for each own property key P of O such that P is a symbol in ascending chronological order of property creation. Do I append P to keys 5. Return keys 0, 1, 1, 2 ordinary object create, prota, additional internal slots list. The abstract operation ordinary object create takes argument prota, an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal 2024 173 that must be defined as part of
Oh yeah, line dialog.
and if additional internal slots list is not provided, a new empty list is used. It performs the following steps when called let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and a D. Shinal internal slots list. Let O be make basic object. Internal slots list. Set O to prota. Return O. 0, 1, 1, 3 ordinary create from constructor. Constructor. Intrinsic default prota. Internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default prota, a string, and optional argument internal slots list, a list of names of internal slots.
You need 2 separate calls.
Containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default prota is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called assert. Intrinsic default prota is the specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the
That's so stupid.
to be. Get prototype from constructor, constructor, intrinsic default prota. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create, prota, slots list, 0, 1, 1, 4 get prototype.
Windows designed their call
Default
to be like the opposite
get prototype from
of the POSIX call,
construct
or POSIX, whatever it is.
and intrinsic default prota, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used
See what chipbout outputs.
responding to a specific constructor. The
So I'm gonna like get this running, I guess.
prototype property, if it exists,
So that's how you do allocation. So
and by intrinsic default prota is used for. It performs the following steps when called assert.
you simply call to allocate the memory,
Name of an intrinsic object.
except with malloc maybe.
Be an intrinsic that is
And you
intended
call it free it.
value of an object.
You pass in the same thing. You passed in here,
Prototype.
or that held what was passed back to use.
Get function realm. Constructor.
If you assign it to some other variable,
Object named intrinsic default.
it doesn't matter if it has a copy. All that matters is that
Object create does
you simply like pass whatever that address is
communicates
back to free.
binary object and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the
And then you don't access it after you call free.
result non-ordinary operations that create
So if something else had a copy of whatever it was,
correctly 107
you access it after it's freed.
and 24.
That's an error.
Constructor does not supply a value, the default value that is used.
So all you gotta do is keep track of where you're using it or whatever. I don't know. It's literally,
Fury 2015
it's not complicated.
slot. O
There's no reason why everybody should be using C++ to
takes argument
use vector.
ECMA script language value
It's like really simple.
internal slot name and returns either a normal
So I don't know, whatever.
store a throw
That's how you do malloc.
exception unless O is an object and has the given
I gotta like try to get this done.
performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused 0.2 ECMA script function objects. ECMA script function objects encapsulate parameterized ECMA script code
See what chipbout says.
and support the dynamic evaluation of that code. An ECMA script function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMA script function object may be either strict mode code 11.2.2 or non-strict code. An ECMA script function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to ECMA
Wow, that's so helpful, chatbot.
the internal slots listed in Table 30. Table 30. Internal slots of ECMA script function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function.
What the heck is a generic version?
Record or null. The private environment record.
Does that mean macro?
Function was.
Or does that mean C++?
Tactically contained within a class. Used
I
as
hope it's not C++.
environment for inner classes when evaluating.
I have a feeling it might be.
Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMA script code. A parse node. The root parse node of the source text that defines the function's body.
This is the same exact thing.
Derived. Whether or not the function is a derived class constructor.
It didn't even like change the size.
The realm in which the function was created and which provides any intrinsic objects that are accessed.
I think chatbot's getting dumber.
Or module. A script record or a module record. The script or module in which the function was created. This mode, lexical, strict, or global, defines how these references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that a this value of undefined or null is interpreted as a reference.
Oh no, there's a difference.
Any other this value I s first passed to object. Copyright sign. ECMA International 2024. 75. Table 30. Internal slots of VC.
How is this helpful at all?
Continued. Internal slot. Type. Description. Strict. A Boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name, a string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field, empty otherwise, is class constructor. A Boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMA script function objects have the internal method defined here. ECMA script functions that are also constructors in addition have the internal method 0, 2, 1. This argument, arguments list. The internal method of an ECMA script function object f takes arguments this argument, an ECMA script language value, and arguments list. A list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If F is true, then A let error be a newly created type error object. B note. Error is created in callee context with F's associated realm record. C remove callee context from the execution context stack and restore caller context as the running execution context. D return throw completion. Error. Perform ordinary.
Oh, I meant genericized.
Callee context. This
Or generic whatever. By meaning like,
ordinary call.
you pass in a different size T for alignment.
Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return if abrupt. Result 0. Return undefined. 176. ECMA International 2024.
I don't know. Let's try this, whatever.
Removed from the execution context stack in step 7. It must not be destroyed.
Get this running.
For later resumption by an accessible generator. 1 0 2 1 1 prepare for ordinary call. F. New tar. Get. The abstract operation prepare for ordinary call takes arguments F, an ECMA script function object. a new target, an object, or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMA script code execution context. Set the function of callee context to F. Let callee realm be F. Set the realm of callee context to callee realm. Set the script or module of callee context to F. Let local env be new function environment, F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env 0. Set the private environment of callee context to F1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note: any exception objects produced after this point are associated with callee realm. 4. Return callee context 0, 2, 1. To ordinary call bind this F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments F, an ECMA script function object, callee context, an execution context, and this argument, an ECMA script language value, and returns unused. It performs the following steps when called. Let this mode be F. If this mode is lexical, return unused. Let callee realm be F. Let local env be the lexical environment of callee context. If this mode is strict, then A. Let this value be this argument 6. Else, A. If this argument is either undefined or null, then I let global env be callee realm. 2. Assert. Global env is a global environment record. 3. Let this value be global env. B. Else, I let this value be. To object, this argument. 2. Note: to object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value 0. Return unused 0, 2, 1. 3. Runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, return, evaluate function body with arguments function object and arguments list, concise body, expression body, return, evaluate concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body, function body, return, evaluate generator body with arguments function object and arguments list. Async generator body, function body, return, evaluate async generator body with arguments function object and arguments list. Async function body, return, evaluate async function body with arguments function object and arguments list. Async concise body, expression body, return, evaluate async concise body with arguments function object and arguments list. Initializer, assignment expression, assert. Arguments list is empty, assert. Function object is not empty. If is anonymous function definition, assignment expression, is true, then A. Let value be named evaluation of initializer with argument function object. Else, A. Let RHS be evaluation of assignment expression. B. Let value be get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert. Arguments list is empty, return, evaluate class static block body with argument function object, 0, 2, 1. For ordinary call evaluate body, F. Arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called return. Evaluate body of f with arguments f and arguments list 1 0 2 2 arguments list. New target. The internal method of an ECMA script function object f takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be f, if kind is base, then a let this argument be. Ordinary create from constructor, new target, %object prototype %. 4. Let callee context be prepare for ordinary call. F. New target, 178, ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this, F. Callee context. This argument, B let initialize result be completion, initialize instance elements. This argument, F. See if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body, F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then A. If result is an object, return result. B. If kind is base, return this argument. C. If result is not undefined, throw a type error exception. 1. Else. A. Return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0, 2, 3 ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points, parameter list, a parse node, body, a parse node, this mode, lexical this or non-lexical this, env, an environment record, and private env, a private environment record or null, and returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1 0 2 1. Set f to source text. Set f to parameter list. Set f to body if the source text matched by body is strict mode code. Let strict be true, else let strict be false. Set f to strict if this mode is lexical this. Set f to lexical 0. Else if strict is true. Set f to strict 1. Else. Set f to global 2. Set f to false 3. Set f to env 4. Set f to private env 5. Set f to get active script or module 6. Set f to the current realm record 7. Set f to undefined 8. Set f to a new empty list 9. Set f to a new empty list 0. Set f to empty 1. Let len be the expected argument count of parameter list 2. Perform set function length f len 3. Return F. ECMA International 2024 179 1024 capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E takes arguments F, a function object, and realm, a realm record, and returns unused. It performs the following steps when called assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called throw a type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5 make constructor F. Writable prototype. Prototype. The abstract operation make constructor takes argument F, an ECMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts F into a constructor. It performs the following steps when called if F is an ECMA script function object, then A assert is constructor, F is false, B assert. F is an extensible object that does not have a prototype own property. C set F to the definition specified in 102, 2 else. A set F to the definition specified in 103, 2 set F to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then A set prototype to ordinary object create. %object prototype %. B perform. Define property or throw. Prototype. Constructor. Property descriptor. F. Writable. Writable prototype. False. True. Perform. Define property or throw. F. Prototype. Property descriptor. Prototype. Writable prototype. False. False. Return unused. 80. ECMA International 2024 102 6 make class constructor F. The abstract operation make class constructor takes argument F, an ECMA script function object, and returns unused. It performs the following steps when called assert. F is false. Set F to true. Return unused. 0, 2, 7 make method F. Home object. The abstract operation make method takes arguments F, an ECMA script function object, and home object, an object, and returns unused. It configures F as a method. It performs the following steps when called set F to home object. Return unused. 0, 2, 8 define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a bool, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called assert. Home object is an ordinary, extensible object. If key is a private name, then A return private element, method, closure 3. Else, A let desk be the property descriptor, closure, true, enumerable, true. B perform. define property or throw, home object, key, desk. C note, define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9 set function name, F, name, prefix. The abstract operation set function name takes arguments F, a function object, and name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to F. It performs the following steps when called assert. F is an extensible object that does not have a name-owned property. If name is a symbol, then A, let description be name's value. B, if description is undefined, set name to the empty string. C, else, set name to the string concatenation of description, and else if name is a private name, then A, set name to name. If F has an internal slot, then A, set F to name. If prefix is present, then A, set name to the string concatenation of prefix. The code unit 0x0020, space, and name. B, if F has an internal slot, then I optionally set F to name. Perform. Define property or throw, F, name, property descriptor, name, false. Enumerable, false. True. Return unused. ECMA International 2024 181. The 10th of February 2010 set function length, F, length. The abstract operation set function length takes arguments F, a function object, and length, a non-negative int, 0+, and returns unused. It adds a length property to F. It performs the following steps when called assert. F is an extensible object that does not have a length-owned property. Perform. Define property or throw, F, length, property descriptor, length, false. Enumerable, false. True. Return unused, 0, 2, 1, 1, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, func, arguments list. The abstract operation, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are re-instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let Corley context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of our declarations, in reverse list order, do A if D is neither a variable declaration nor a binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then, a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then, a set arguments object needed to false. 82. ECMA International 2024. 18. Else if has parameter expressions is false. Then, a if function names contains arguments or lexical names contains arguments. Then, I set arguments object needed to false. 9. If strict is true or has parameter expressions is false. Then, a note, only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding, param name. B note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. C if already declared is false. Then, I perform env create mutable binding, param name, false. 2. If has duplicates is true, then, perform env initialize binding, param name, undefined. 22. If arguments object needed is true, then, a if strict is true or simple parameter list is false. Then, I let aob create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let aob create mapped arguments object, func, formals, arguments list, env. See if strict is true, then, I perform the env create a mutable binding, arguments, false. 2. Note, in strict mode code early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform env create mutable binding, arguments, false. E perform env initialize binding, arguments, a, o, f let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If has duplicates is true, then, a perform iterator binding initialization of formals with arguments iterator record and undefined. 26. Else, a perform iterator binding initialization of formals with arguments iterator record and env. 27. If has parameter expressions is false, then, a note, only a single environment record is needed for the parameters and top-level vars. B let instantiated var names be a copy of the list parameter bindings. C for each element n of a var names, do I if instantiated var names does not contain n, then, append n to instantiated var names. Perform env create mutable binding, n, false. Perform env initialize binding, n, undefined. D let var env be env 28. Else, a note, A separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B. Let var env be new declarative environment. env. C. Set the variable environment of callee context to var env. D. Let instantiated var names be a new empty list. E. For each element n of a var names, do. I. If instantiated var names does not contain n, then, ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding, n, false. If parameter bindings does not contain n, or if function names contains n, then, A. Let initial value be undefined for. Else, A. Let initial value be env get binding value, n, false. Perform var env initialize binding, n, initial value. Note: a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note: an xb 3, 2, 1 adds additional steps at this point. 0. If strict is false, then a let lex env be new declarative environment, var env. B. Note: non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var-scoped declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lex env be var env. 2. Set the lexical environment of callee context to lex env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element d of lex declarations, do. A note: a lexically declared name cannot be the same as a function-generated declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B. For each element dn of the bound names of d, do. I. If his constant declaration of d is true, then perform lex env create a mutable binding, dn, true 2. Else, perform lex env create mutable binding, dn, false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do. A. Let fn be the sole element of the bound names of f. B. Let fo be instantiate function object of f with arguments lex env and private env. C. Perform var env set mutable binding, fn, fo, false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 103. 1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 103. 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMA script that predate ECMA script 2015. 84. Copyright sign, ECMA International 2024 103 1. This argument, arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f. This argument, arguments list, undefined 103. 2. Arguments list, New target, the internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called return, built-in call or construct, f, uninitialized, arguments list, new target 103, 3 built-in call or construct, f. This argument, arguments list, new target, the abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMA script language value or uninitialized, arguments list, a list of ECMA script language values, and new target, a constructor or undefined, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record, that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, for create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior and abstract closure, a set of algorithm steps, or some other definition of a function's behavior provide. D in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string, and returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note, when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024-185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let func be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null. 0. Perform set function length, func, length 1. If prefix is not present, then A performs set function name, func, name 12. Else, A performs set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if it's and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMA script function objects listed in Table 30. Instead, they have the internal slots listed in Table 31. In addition to and Table 31, internal slots of bound function exotic objects. Internal slot, type, description, bound target function, a callable object, the wrapped function object, bound this, an ECMA script language value, the value that is always passed as the this value when calling the wrapped function, bound arguments, a list of ECMA script language values, a list of values whose elements are used as the first arguments to any call to the wrapped function. 186, ECMA International 2024, 10411. This argument, arguments list. The internal method of a bound function exotic object F takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called: let target be F, let bound this be F, let bound args be F, let args be the list concatenation of bound args and arguments list. Return, call, target, bound this, args 0, 4, 1, 2, arguments list. New target, the internal method of a bound function exotic object F takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: let target be F, assert, is constructor, target, is true, let bound args be F, let args be the list concatenation of bound args and arguments list, if same value, F, new target, is true, set new target to target, return, construct, target, args, new target, 0, 4, 1, 3 bound function create, target function, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMA script language value, and bound args, a list of ECMA script language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called: let proto be target function, let internal slots list be the list concatenation of, and the internal slots listed in Table 31, let obj be make basic object, internal slots list, set obj to proto, set obj as described in 10411. If is constructor, target function, is true, then a set obj as described in 10412. Set obj to target function, set obj to bound this, set obj to bound args 0. Return obj 0, 4, 2 array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index, whenever an own property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever an own property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, Every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index. Properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desk. The internal method of an array exotic object A takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desk. Else if p is an array index, then a let length desk be ordinary get own property a length b assert is data descriptor length desk is true. C assert length desk is false. D let length be length desk. E assert length is a non-negative integral number. F let index be 232 p. G if index length and length desk is false, return false. H let succeeded be ordinary define own property a p desk. I if succeeded is false, return false. J if index length, then I set length desk to index plus 1 2. Set succeeded to ordinary define own property a length desk 3. Assert succeeded is true. K return true. Return ordinary define own property a p desk 0, 4, 2, 2 array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto, an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232.1, throw a range error exception. If proto is not present, set proto to array prototype let a be make basic object. Set a to proto. Set a as specified in 1 0, 4, 2, 1. Perform ordinary define own property a length property descriptor length true false return a 0, 4, 2, 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array if is array is false. Return array create length let is be get original array constructor if is constructor. C is true. Then 88 ECMA International 2024. A let this realm be the current realm record. B let rearm be get function realm. C if this realm and rearm cannot the same realm record. Then I if same value C rearm is true. Set C to undefined. If C is an object, then A set C to get C at species. B if C is null, set C to undefined. If C is undefined, return array create length. If is constructor, C is false. Throw a type error exception. Return construct C length 0, 4, 2, 4 array set length A desk. The abstract operation array set length takes arguments a, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define own property a length desk. Let new len desk be a copy of desk. Let new len be 232 desk. Let number len be to number desk. If same value 0, new len number len is false. Throw a range error exception. Set new len desc to new len. Let old len desc be ordinary get own property. A length assert is data descriptor. Old len desc is true. Assert old len desc is false. 0. Let old len be old len desc. 1. If new len old len, then a return ordinary define own property. A length new len desc. 2. If old len desc is false, return false. 3. If new len desc does not have a field or new len desc is true, then a let new writable be true. 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B. Let new writable be false. C. Set new len desc to true. 5. Let succeeded be ordinary define own property. A length new len desc. 6. If succeeded is false, return false. 7. 4. Each own property key P of A such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded be A P. B. If delete succeeded is false, then I set new len desc to 32 P plus 1. 2. If new writable is false, set new len desc to false. 3. Perform ordinary define own property. A length new len desc. 5. Return false. 8. If new writable is false, then A set succeeded to ordinary define own property. A length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desc is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0. 4. 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer indexed data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called let desc be ordinary get own property, S, P. If desc is not undefined, return desc, return string get own property, S, P. 0, 4, 3, 2, P. Desc. The internal method of a string exotic object S takes arguments P, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called let string desc be string get own property, S, P. If string desc is not undefined, then a let extensible be S. B return is compatible property descriptor, extensible, desc, string, ng desc, return, ordinary define own property, S, P, desc, 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str for each integer I such that 0I, len, in ascending order. Do a append to string I to keys for each own property key P of O such that P is an array index and to integer or infinity P len, in ascending numeric index order. Do I append p to keys for each own property key p of O such that p is a string and p is not an array index. In ascending chronological order of property creation, do I append p to keys? 90. ECMA International 2024. 8. For each own property key p of O such that p is a symbol, in ascending chronological order of property creation, do I append p to keys? 9. Return keys 0, 4, 3, 4 string create, value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called let s be make basic object, set s to prototype, set s to value, set s is specified in 1 0, 4, 3, 1, set s is specified in 1 0, 4, 3, 2, set s is specified in 1 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw, s, length, property descriptor, length, false, enumerable, false, false, return s, 0, 4, 3, 5 string get own property, s, p. The abstract operation string get own property takes arguments s, an object that has an internal slot, and p, a property key, and returns a property descriptor or undefined. It performs the following steps when called if p is not a string, return undefined. Let index be canonical numeric index string, p. If index is undefined, return undefined. If is integral number, index, is false, return undefined. If index is -0, return undefined. Let str be s. Assert. Str is a string. Let len be the length of str. If index, 0 or len index, return undefined, 0. Let result str be the substring of str from index, to index, plus 1, 1. Return the property descriptor, result str, false, true, false, 0, 4, 4 arguments exotic objects. Most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. CT. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2 0, 1, 3, 6. To identify them as such. Note 1 while create a mapped arguments object is grouped into this clause. It creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer, indexed data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments, objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note: 5 ECMA script implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor 0441p. The int runal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called: let desc be ordinary get own property, args p. If desc is undefined, return undefined. Let map be args, let is map be. Has own property, map p. If is mapped is true, then a set desc to get map p6. Return desc 0442p. Desc. The internal method of an argument's exotic object args takes arguments p, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called: let map be args, let is map be. Has own property, map p. Let mu arg desc be desc. If is mapped is true and is data descriptor, desc, is true, then a. If desc does not have a field, desc has a field, and desc is false, then I set mu arg desc to a copy of desc. 2. Set mu arg desc to get map p. Let allowed be ordinary define own property args p. New arg desc. if allowed is false, return false. If is mapped is true, then A. If is accessor descriptor, desk, is true, then I perform map, P. B else I. If desk has a field, then assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map P desk false. 2. If desk has a field and desk is false, then perform map P8 return true. 0 4 4 3. The let map be args let is map B has own property map P. If is mapped is false, then A return ordinary get args P receiver 4 else A assert map contains a formal parameter mapping for P. B return get map P 0 4 4 4. The if same value args receiver is false, then A let is map be false. Else A let map be args B let is map B has own property map P. If is mapped is true, then A assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable. B perform set map P V false return ordinary set args P V receiver 0 4 4 5 P. The internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called let map be args let is map B has own property map P let result B ordinary delete args P. If result is true and is mapped is true, then A perform map P5 return result. ECMA International 2024 193 104 4 6. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMA script language values, and returns an ordinary object. It performs the following steps when called let len be the number of elements in arguments list. Let obj be ordinary object create %object prototype set obj to undefined. Perform define property or throw obj length property descriptor len true enumerable false true. Let index be 0 repeat while index len a let val be arguments list index dart b perform create data property or throw obj to string index val c set index to index +1. Perform define property or throw obj at iterator property descriptor %array prototype values true false true. Perform define property or throw obj callee property descriptor %throw type error false false. Return obj 0 4 4 7. Create mapped arguments object func formals arguments list env. The abstract operation create mapped arguments object takes arguments func an object formals a parse node arguments list, a list of ECMA script language values, and env an environment record, and returns an argument's exotic object. It performs the following steps when called assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj as specified in 1 0 4 4 1. Set obj as specified in 1 0 4 4 2. Set obj set obj set obj as specified in 1 0 4 4 5. Set obj to %object prototype %0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat while index len a let val be arguments list index b perform create data property or throw obj, to string, index, val, c set index to index plus 1, 6. Perform. Define property or throw, obj, length, property descriptor, len, true, false, true. 7. Let mapped names be a new empty list. 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If mapped names does not contain name, then I append name to mapped names. 2. If index, len, then let G be make arggetter, name, env. Let P be make argsetter, name, env. Perform map. To string, index, property descriptor, get, G, false, true. Set index to index 1, 20. Perform. Define property or throw, obj, at iterator, property descriptor, percent array prototype values percent, true, false, true. 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true. 2. Return obj, 0, 4, 4, 7, 1 make arggetter, name, env. The abstract operation make arggetter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name in env. It performs the following steps when called. Let getAClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getAClosure, 0. Note. Getter is never directly accessible to ECMA script code. Return getter, 0, 4, 4, 7, to make argsetter, name, env. The abstract operation make argsetter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name in env. It performs the following steps when called. Let setAClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setAClosure, 1. Note. Setter is never directly accessible to ECMA script code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally, length, and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined, then I let value be typed array a get element, O, numeric index. 2. If value is undefined, return undefined. 3. Return the property descriptor, value, true, true, true. Return ordinary get own property, O, P. ECMA International 2024 195 10 4 5 2 P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then A let numeric index be canonical numeric index string, P. B if numeric index is not undefined, return is valid integer index, O, numeric index. Return. Ordinary has property O, P. 0, 4, 5, 3, P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk. a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called if p is a string. Then, a let numeric index be canonical numeric index string, p. b if numeric index is not undefined. Then, I if is valid integer index, o, numeric index, is false. Return false. 2. If desk has a field and desk is false, return false. 3. If desk has a field and desk is false, return false. 5. If is access a descriptor, desk, is true, return false. V if desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element, O, numeric index, desk. 7. Return true. Return. Ordinary define own property, O, P, desk. 0, 4, 5, 4. The, if P is a string, then, a let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I return typed array a get element, O, numeric index 2. Return. Ordinary get, O, P, receiver 0, 4, 5, 5. The, if P is a string, then, a let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I if same value, O, receiver, is true. Then, perform. Typed array set element, O, numeric index, V. Return true. 2. If is valid integer index, O, numeric index, is false, return true. Return. Ordinary set, O, P, V, receiver, 96. ECMA International 2024, 10, 4, 5, 6, P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called if P is a string. Then, a let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I if is valid integer index, O, numeric index, is false. Return true, else return false. 2. Return. Ordinary delete, O, P, 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sex EST. Let keys be a new empty list. If is typed array out of bounds, tar record, is false. Then, a let length be typed array length, tar record, be for each integer I such that 0I, length, in ascending order, do I append to string, I, to keys, for each own property key P of O such that P is a string and P is not an integer index, in ascending chronological order of property creation, do I append P to keys, for each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do I append P to keys. 6. Return keys, 0, 4, 5, 8. Typed array with buffer witness records, and typed array with buffer witness record is a record value used to encapsulate a typed array along with the cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, B, J. Order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sex est or unordered, and returns a typed array with buffer witness record. It performs the following steps when called let buffer be obj if is detached buffer is true. Then, a let byte length be detached, field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded, cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record, obj, byte length 0, 4, 5, 1, 0 typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called let internal slots list be. Let A be make basic object, internal slots list, set A as specified in 1, 0, 4, 5, 1, set A as specified in 1, 0, 4, 5, 2, set A as specified in 1, 0, 4, 5, 3, set A as specified in 1, 0, 4, 5, 6, set A as specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length, tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called if is typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O, return length element size 0, 4, 5, 1, 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called assert. Is typed array out of bounds, tar record, is false. Let O be tar record. If O is not auto, return O. Assert. Is fixed length array buffer, O, is false. Let byte offset be O. Let element size be typed array element size, O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length, byte offset, element size 0, 4, 5, 1, 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a Boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer, O, is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O, B let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1, 4 is valid integer index. O, index. The abstract operation is valid integer index takes arguments O, a typed array, and index, a number, and returns a Boolean. It performs the following steps when called if is detached buffer, O, is true, return false. If is integral number, index, is false. return false. If index is -0, return false. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If R index 0 or R index length, return false, return true. 0, 4, 5, 1 5 typed array a get element O index. The abstract operation typed array a get element T x arguments O, a typed array, and index a number, and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index O index is false, return undefined. Let offset be O. Let element size be typed array element size O. Let byte index in buffer be R index element size plus offset. Let element type be typed array element type O. Return get value from buffer O. Byte index in buffer element type true. Unordered 0, 4, 5, 1 6 typed array set element O index value. The abstract operation typed array set element takes arguments O, a typed array, index, a number, and value, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To bigint, value. Otherwise, let num value be. To number, value. If is valid integer index O index is true, then A let offset be O. B let element size be typed array element size O. C let byte index in buffer be R index element size plus offset. D let element type be typed array element type O. E perform set value in buffer O. Byte index in buffer element type num value true. Unordered return unused. ECMA International 2024 199 10 4 5 17 is array buffer view out of bounds O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has their internal slot, then A let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexy S T B return is view out of bounds. View record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy S T return is typed array out of bounds. Tar record 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMA script module. C16, 2, 3. There is a one-to-one correspondence between the string keydone properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value done property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its comma and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module. A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using a undefined as compare f 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called return null 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer 1 0 4 6 2 v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called 1. Return. Set immutable prototype O v 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called return false 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called return true 0 4 6 5 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called if p is a symbol. Return ordinary get own property O p. Let exports be O. If exports does not contain p, return undefined.
For Windows, I think it needs to be like aligned by,
True, true, false.
or the size that's allocated needs to be a multiple
The internal method of a module namespace exotic
of whatever the type is,
and desk.
or whatever the allocation is.
There are normal completion containing a boolean or a throw completion.
Like it has to match the alignment or whatever.
When called if p is a symbol, return. Ordinary define own property O p. Desk. Let current
64.
current is undefined. Return false. If desk has a field and desk is true, return false. If desk has a field and desk is false, return false. If is access a descriptor, desk is true, false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk.
Can't I just like
4 6 7 p. The internal method of a module namespace exotic object O takes argument
figure out how many times that
containing
the size to allocate for the type
the following steps
fits
symbol, return. Ordinary has
into like 64 byte chunks,
exports BO. If exports contains p,
and save the remainder,
return false.
then multiply by that to scale whatever,
1 0
then add the remainder.
6 8. The if p is a symbol,
Because if I just like shift left
p
to multiply by 64
exports BO. If exports does
by a multiple,
return undefined. Let m be
I think that adds padding every time.
p. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a
I don't want to call module every time.
0. Let target env.
I don't know, that's chatbot.
If target env is empty, throw a reference error exception. 2. Return target env get binding value. Binding. True.
So like, I don't know, it's only a couple micros.
9.
To set up, it's good.
10. 4. 6. 10.
There's a lot of types.
Method of a module namespace exotic.
So to make sure it's solid, and then duplicate it for the rest.
Returns a normal completion.
So much fun,
It performs
but not really.
when called if p is a symbol, then a return. Ordinary delete. O. When called let keys be ordinary ow and property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache
Chatbot should be able to figure it out.
object 0
I can always check it, whatever.
2004
Like Chatbot can't do assembly.
6
This is like simple stuff.
module exports. The abstract operation module namespace
So it's a Chatbot, whatever.
will record
Yeah, this is so boring.
list of strings and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called assert. Module is empty. Let internal slots list be the internal slots listed in table 33. Let m be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 10. 4. 6. Set m to module. Let sorted exports be a list whose elements are the elements of export sorted as if an array of the same values had been sorted using %array prototype sort % using a undefined as compare f. Set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0. 4. 7. Immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0. 4. 7. 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called return. Set immutable prototype. O. V10. 4. 7. To set immutable prototype. O. V. The abstract operation set immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called let current be. O. If same value, V, current, is true. Return true. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMA script code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy objects into null methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments, and in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024-203, slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. Proxy handler methods, internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has get, set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMA script code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMA script implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMA script proxy object, P is a property key value, V is any ECMA script language value, and desc is a property descriptor record. 04. Copyright sign, ECMA International 2024 1051. The F internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, get prototype of if trap is undefined. Then, a return target, let handler proto be. Call, trap, handler, target, if handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible, target, 0. If extensible target is true, return handler proto, 1. Let target proto be target, 2. If same value, handler proto, target proto, is false, throw a type error exception. 3. Return handler proto, 0, 5, 2, V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, set prototype of if trap is undefined. Then, a return target V, let boolean trap result be to boolean. Call, trap, handler, target, V. If boolean trap result is false, return false. Let extensible target be. Is extensible, target, 0. If extensible target is true, return true, 1. Let target proto be target, 2. If same value, V, target proto, is false, throw a type error exception. 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 10 5 3. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target capital L at boolean trap result be
Alright, I got a better way.
trap. Handler target let target result be is extensible. Target if boolean trap result is not target result, throw a type error exception 0. Return boolean trap result 0. 5. 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion.
So like instead,
Throw completion.
I'm just gonna mask
Following steps when called perform. Validate.
the bottom 5 bits.
O. Let target be O. Let handler be O. Assert. Handler is an object.
Then if any of those bits are set,
Method. Handler.
then I add,
Trap is undefined.
or I don't even add, I just like
Let boolean trap result be to boolean.
multiply the result by one more.
Target. If boolean trap result is true, then a let extensible target be is extensible. Target b if extensible target is true. Throw a type error exception. Return boolean trap result 0. 5. 5. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoked proxy. O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target P. Let trap result OBJB. Call. Trap. Handler. Target. P. If trap result OBJ is not an object and trap result OBJ is not undefined, throw a type error exception. Let target desk be target P 0. If trap result OBJ is undefined, then A if target desk is undefined. Undefined. B if target desk
Can't I just like
exception.
add a 1
B is
to whatever it needs to multiply by then?
extensible target is false. Throw a type error exception.
Because if there's any remainder,
1.
it like spills.
Hit B is extensible. Target 2. Let result
So if I add like one more 64 byte,
trap result
bytes whatever, alignment,
complete property
then it won't spill whatever. It will spill, but like not beyond, but within the next one.
result desk. Target ESC 5. If valid is false, throw a type error exception. 6. If result desk is false, then A if target desk is undefined or target desk is true, then I throw a type error exception. B if result desk has a field
Pretty sure that work.
false, then I assert target desk has a field 2. If target desk is true, throw a type error.
See if Chip has a better idea.
Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent.
This is like a whole lot of operations.
Property of the target object.
I was thinking like I'd save the two values
It exists.
for one of them and add it.
Principal target object.
This is like plus, divide, multiply, times,
The known property of
then count. I don't know. Chatbot's really,
a property cannot
I don't know what Chatbot's doing.
unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0. 5. 6. P.
So I'll paste this into chatbot a second.
The exotic object O takes arguments P,
Size of type and
desk,
0 or 64 minus 1.
completion containing a boolean or a
The mask.
It performs the following steps when called perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, define property if trap is undefined. Then,
Let's use a ternary. I don't care.
let desco be JB from property descriptor. Desk, let boolean trap result be to boolean. Call, trap, handler, target, P. Desco bj if boolean trap result is false. And false, 0. Let target desk be target P.
Yeah, it's a bug me if I do.
And 24207, 11. Let extensible target be. Is extensible, target, 2. If desk has a field and desk is false, then a let setting config false be true 13. Else, a let setting config false be false, 4. If target desk is undefined, then a if extensible target is false, throw a type error exception. B if setting config false is true, throw a type error exception. 5. Else, a if is compatible property descriptor, extensible target, desk, target desk, is false. Throw a type error exception. B if setting config false is true and target desk is true, throw a type error exception. C if is data descriptor, target desk, is true, target desk is false, and target desk is true. Then, I if desk has a field and desk is false, throw a type error exception. 6. Reto.
So, whatever the result is,
Objects enforces the following invariants. The result of is a boolean value. A property
negate it.
The target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable
Cast it assigned.
unless there exists a corresponding non-configurable non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, has, if trap is undefined. Then, a return target P, let boolean trap result be to boolean. Call, trap, handler, target, P,
64 minus 1.
false.
This wrapped here.
Desk be target P, B if target desk is.
Let's wrap this again.
Then, I if target desk is.
So this result negated.
2. Let extensible target be.
It gets back to unsigned. 64-bit.
If
Because it doesn't always
type error exception.
right shift 64 if it truncates to 32-bit.
ECMA International 2024. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be
So freaking boring.
if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoked proxy. O, let target be O, let handler be O, assert.
So this gives me the mask
Trap B. Get
to get the bottom 5 bits.
if trap is undefined.
And the size of type.
Let trap result be. Call.
I get the number. I get like if any bytes are remaining.
Desk B target P. If target desk is not
I negate it to set the sign bit. Like flip the number.
data
Because it's only true that it's opposite if it's non-zero.
then
Otherwise 0, 0.
trap result
Cast it to size T, 64 whatever.
and B if
It's unsigned.
target desk.
Right shift 60
Return trap result. Note, the value
3 bits whatever.
is the value of the corresponding target
Then the bit's set if it's true that
and writable, non-config.
it needs to take up one more 64 byte granular unit
object prop
because it's going to spill. So it's only true when there's bit set.
5, 9. The perform. Validate non-revoked proxy. O. Let target be O. Let handler be.
So this needs to be added.
Is an object. Let trap be. Get method. Handler. Set. If trap is undefined. Then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. V. Receiver. If boolean trap result is false. Return false. Let target desk be target P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. A if is data descriptor, target desk is true and target desk is false.
Would it be better add before the multiply or after?
Is false. Throw a type error exception. B if is accessor descriptor, target desk is true. Then I if target desk 1. Return true. Note, the result of cannot change the value of a
Probably before.
corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property, cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion.
Because the multiply is a heavier instruction.
Validate non-revoked proxy.
And adding it after the multiply
Assert.
would probably be a longer delay.
Let trap be. Get method. Handler.
And adding it
Is undefined.
means I'd have to multiply it by
Boolean trap result.
64.
Call. Trap. Hand.
So if I add it to what's being multiplied by,
Boolean trap result is false. Return false. Let target desk be target P.
it's less instructions, whatever.
Return
Or not. Who knows what the compiler would do.
is false.
Compiler sucks.
Exception 2. Let extensible target be. Is extensible. Target 3. If extensible target is false. Throw a type error exception. 4. Return true. Note the proxy objects enforces the following invariants. The result
Count.
a property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property
Plus
and the target object is non-extensible. 0.
this. So 0, 1 times
Exotic object O takes no arguments and
sensitive type.
completion containing a list of property keys or a throw completion. It performs the following steps when called
Possibly.
non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler.
So I don't know. That's like, I'm not really thinking about it.
And 24.
Let's check out if
Then a return
what its simplest
call. Trap.
solution is.
Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, throw a type error exception. 0. Let extensible target be. Is extensible. Target 1. Let target keys be target 2. Assert. Target keys is a list of property keys. 3. Assert. Target keys contains no duplicate entries.
A message about
Get config
is there a better way?
empty list. 5. Let target non-configurable keys be a new
What is your solution that would involve least computation,
do.
most performant?
Target key. B if desk is not undefined and desk is false. Then I append key to target.
It says if your goal is pure speed,
I append key to target.
you don't care about a couple bytes over allocation.
Possible target is true and
That's its approach.
then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do. A if unchecked result keys does not contain key, throw a type error.
Oh, I guess what's it doing here?
Key from unchecked result keys. 0. If extensible target is
Plus 63.
1. For each element key of target configurable keys, do. A. If unchecked result keys does not contain key, throw a type error exception. B. Remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariants. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all keys of the target object. If the target object is not extensible, then the result list must contain all the keys of the own property.
Okay, so instead,
No other values. 0.
chatbot's adding 63 bytes.
Arguments list. The internal method of a proxy exotic object takes arguments. This argument
To get it to the multiple,
language value
or like one above.
list. A list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called perform. Validate non-revoked proxy. O. Let target be.
Chatbot's adding this to this.
Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then A. Return. Call. Target. This argument. Arguments list. Let array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. Array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024-211, the 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object takes arguments list. A list of ECMA script language values, and new target, a constructor, and returns either a normal completion.
Oh, it's 6 bits for 64-bit.
It performs the following steps.
Not 5.
Validate non-revoked proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap.
Really didn't add.
Handler.
That's cool.
If trap is undefined, then A. Return. Construct. Target. Arguments list. New target. Let array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0. 5. 1. 4. Validate non-revoked proxy. Proxy. The abstract operation validate non-revoked proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Proxy is not null, return unused. 0. 5. 1. 5. Proxy create. Target. The abstract operation proxy.
Does that work?
ECMA script language value, and handler, an ECMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except for end, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2000.
Wait, it might work.
To target, set P to handler, return P. 12. ECMA International 2024. Note 1A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMA script language. Source text 1.
63 plus 63. Always that carry.
Code point.
Because they're both the same size.
Next is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMA script source text where permitted by the ECMA script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMA script implementation process is the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMA script implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular
63 bytes.
Literals and
64. That's not much waste.
may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMA script differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000A, for example, occurs within a single line comment, it is interpreted as a line terminator Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator. Which is not allowed within a string literal, one must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMA script program, the Unicode escape sequence occurring in a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMA script program always contributes to the literal and is never interpreted as a line
Pretty sure it's 3F.
might terminate the
3F.
1 static semantics. UTF-16 encode code point. CP, the abstract operation UTF-16 encode code point takes argument CP, the Unicode code point, and returns a string. It performs the following steps when called assert. 0 CP0x10FF. If CP0xFF, return the string value consisting of the code unit whose
So this will
numeric value is floor. CP0x10,000, 0x400,
only add 64 bytes
to be the code unit whose numeric value is CP0
if it needs it. If it fits within,
400
it won't add it.
DC00. Return the string concatenation of Q1 and Q2.
Except that's only the case
13 1 1 1 2 static
when it's actually equal.
string text. The abstract operation code points to string takes argument
When it's not equal to alignment,
code points and return
or when it's less than 64 bytes.
enter a string value as described in 6 1 4.
So it's probably better just to add 64 bytes.
Result be the empty string. For each code point CP of text, do a set result to the
Every time.
result and UTF-16 encode code
So it's probably better than this.
3. Return result 1 1 3 static semantics. UTF-16 surrogate pair to code point. Lead, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead, a code unit and
But it might not be.
code unit and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xD800, 0x400 plus, trail 0xDC00, plus 0x10,000. Return the code point CP 1 1 4 static semantics. Code point at string position. The abstract operation code point it takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6 1 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps.
The typecasts don't cost anything.
Insert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If first is neither a leading surrogate nor a trailing surrogate, then A return the record. CP 1.
I like this part. It says,
Is a trail.
your method is less clear to maintainers
Then A
and likely to confuse the next person reading your code.
T ru. Let second be
Why would somebody be reading my code?
is not a trailing surrogate.
Why do you always have to count for someone else reading your code?
True. Set CP
Because the whole thing's set up
first.
so somebody will be reading your code.
Turn the record.
So you should of course write your code for the next person that reads it.
5.
The next person that steals it, so it's easier for them to read. You don't want to confuse them.
String to code points take
I mean, if someone's going to steal your code, you want to make it easy.
list of code points.
Unless, of course, you're actually writing it for, like, open source, and your intention is to make it easy to read.
Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position size. Let CP be code point at string. Position be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024 111.
I gotta test it or check it.
Text. Source.
Say, hey, chatbot.
Symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also Clause 17. 1.2 Types of source code. There are 4 types of ECMA script code. Global code is source text that is treated as an ECMA script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, a sync function declaration, a sync function expression, a sync generator declaration, a sync generator expression, method definition, arrow function, a sync arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMA script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the E and internal slots, see 10.2, of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, a sync function declaration, a sync function expression, a sync generator declaration, a sync generator expression, method definition, arrow function, a sync arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any, of that declaration or expression is also included in the function code of the corresponding function. Module code is source text, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions. 15.2. Arrow function definitions. 15.3. Method definitions. 15.4. Generator function definitions. 15.5. Async function definitions. 15.8. Async generator function definitions. 15.6. And async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1, the generator function constructor 27, 3, 1, 1, and the async function constructor 27.
Alright, the chatbot's macro.
1. Note to the practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues and use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1, 2. 2 strict mode code. An ECMA script syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4, 3, 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition,
Okay, so far,
or async
chatbot looks faster.
contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructors as strict mode code if the last argument is a string that when processed is a function body that begins with a directive prologue that contains a use strict directive. ECMA script code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use-strict directive and which occur in a directive prologue, if an appropriate notification mechanism exists. An implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use-strict directive and which does not have a meaning defined by the implementation. 1.1, 2, 3 non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA script source text. Whether a function object is defined within ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the The input element hashbang or EGXP goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: A equals B high G exec, CMAP, D, where the first non-white space, non-comment code point after a line terminator is U plus 002F, Solidus, and the syntactic context allows division or division assignment, no semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as A equals B high G exec, CMAP, D, syntax, input element div, white space, line terminator comment common token div punctuator right brace punctuator, input element regexp, white space, line terminator comment common token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment common token regular expression literal template substitution tail, input element template tail, white space, line terminator comment common token div punctuator template substitution tail, input element hashbang or EGXP, white space, line terminator comment common token hashbang comment regular expression literal. 2.1 Unicode format T control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as
What if?
or right to left mark, Our control code
Because I am adding too many,
text in the absence of higher level
or too much, whatever, it's gonna overflow.
such as markup language.
What if I just add one
Control characters in source text to
and master result?
and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals, U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMA script source text, these code points may also be used in an identifier name after the first character. U plus FF, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order, ZWNBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMA script source text, ZWNBSP, code points are treated as white space characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FF 0 width no break space ZWNBSP white space 218 ECMA International 2024 12.2 white space. White space code points are used to improve source text readability and to separate tokens, indivisible lexical units from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMA script white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation.
So I'm gonna try this.
B. Line tabulation. VT. U plus 000C. Form feed.
I'm so bored. I gotta do something.
F.
It's less boring, but still boring.
WNBSP. Any
There's plenty more things more exciting than this.
operator. Note 1 U plus 0020. Space. And U plus 00A0. No break space. Code points are part of USP syntax. Note 2 other than for the code points listed in Table 36. ECMA script white space intentionally excludes all code points that have the Unicode white space property but which are not classified in general category space separator ZEDS 2.3 white space tab VT FF ZWNBSP USP line terminators like white space code points. Line terminator code points
What if I do this?
source text readability and to separate tokens, indivisible lexical units from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion, 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF, and CR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024 219. The ECMA script line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point Unicode name abbreviation U plus 000A line feed LF U plus 000D carriage return CR U plus 2028 line separator LS U plus 2029 paragraph separator PS. Only the Unicode code points in table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in table 36. The sequence CR LF is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting
Here's the size of ratio 6.
LF CR LS PS line terminator sequence LF CR look ahead LF LS PS CR LF 2.4 Comments can be either single or multi-line.
Times multiple amount.
A single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single.
Then
It is recognized separately by the lexicon
how do I
part of the stream of input
one less instruction?
It is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax, comment, multi-line comment, single line comment. 20. ECMA intonation R L 2024. Multi-line comment chars opt, multi-line comment chars, multi-line not asterisk char, multi-line comment chars opt, post asterisk comment chars opt, post asterisk comment chars. Capital M U L T I capital L I N E capital N O T capital F O R W A R D capital S L A S H capital O R capital A S T E. Multi-line comment chars opt, post asterisk comment chars opt, multi-line not asterisk char, source character but not. Capital M U L T I capital L I N E capital N O T capital F O R W A R D capital S L A S H capital O R capital A S T E. Source character but not one of all. Single line comment chars opt, single line comment chars, single line comment char, single line comment chars opt, single line comment char. Source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and, like other types of comments, are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single line comment chars opt. 2.6 Token syntax. Common token. Private identifier punctuator.
This is faster.
Note the div punctuator, regular expression literal, right brace punctuator, and template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024 221. 12.7 Names and
Chatbot, which is faster.
man reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard and X number 31.
Put in like a new tab because it's gonna remember and then lie to me
Reserved word is an enumerator
if it knows the context.
by name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points in the specified categories in the latest version of the Unicode
This keyboard's not working.
categories by or conforming ECMA script implementations. ECMA script
No, it's a stupid program. Web.
defined in late
It's like
standard syntax
adding a bunch of spaces and shit.
Identifier name. Identifier name. Identifier start. Identify.
Trying to format as I type.
Identifier start. Identifier start char. Unicode escape sequence. Identifier part. Identifier part char. Unicode escape sequence.
I missed chatbot.
Start char.
Which of these?
D start. Underscore. Identifier part.
2,
Code ID continue. ZWNJ.
x86,
ASCII letter. One of A, B,
64,
D, E, F, G,
routines,
I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, capital A, capital
will be faster,
E, capital
or will be more performant than the other.
Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue.
In
Point with the Unicode property ID continue. The definitions of
a high performance
Unicode escape sequence is given in 1, 2, 9, 4. Note 1 this
scenario
code point additions. U plus 0
where every instruction,
sign and U plus 005F
every clock cycle counts.
are permitted anywhere in an identifier name, and the code points U plus 200C, 0 with non-joiner, and U plus 200D, 0 with joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note to the non-terminal identifier part derives via Unicode ID continue. 2. 7. 1 identifier names. Unicode escape sequences are permitted in an identifier
Where the most optimal solution is needed,
code point equal
even if that is a small amount.
escape sequence. The preceding the Unicode escape sequence does not contribute any code.
Or even if it's a hair faster.
Sequence cannot be used to
Even if it's only a hair.
a name that would
A hair quicker.
words. If a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this
Open like
on their actual
a different tab, browser, whatever.
sequence was used to contribute any particular code point to
There's Firefox.
that are canonically equivalent according to the
It's received it to a cookie, so it's probably going to be able to find it anyways.
Unicode escape
The context of the last question, whatever.
same sequence of code points. 2, 7, 1. 1 static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of the Unicode escape
Alright, so that's the chatbot.
code point matched
Which of these x86, 64 routines will be more performant than the other
part.
in a high performance scenario where every clock cycle counts,
Error if identifier code
but spelling doesn't matter?
escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production.
CYCLE.
1. 2 static semantics. Identifier code point
Where the most optimal solution is needed, even if it's only a hair quicker.
of code points.
A or B.
Piecewise over the following productions. Identifier name. Identifier start. Let CP be
Oh my god.
start. Return CP. Identifier name.
Unusual activity. What?
Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier
For the love of cheese
concatenation of CPS and
and all that is Parmesan.
3 static semantic.
Come on.
The syntax directed operation
Script.
code point takes no arguments and returns a code point.
It's gonna know the context. It's gonna lie to me.
Identifier start. Identifier start char. Return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue.
Oh my god, I'm not gonna log in.
24223. Identifier part. Identifier part char. Return the code point match.
Really? Do you really want people to log in?
U hex 4 digits. Return the code point whose numeric value is
Well, chatbot's gonna lie.
Unicode escape sequence.
Whatever. I'll just ask anyways.
and the code point whose numeric value is the MV of code point. 2.
It says, let's carefully analyze both.
Words.
What chatbot's like. Let's figure out which one would be mine and which one's yours. I'll tell you that mine's faster.
Font. In some syntactic production.
So it says, 1 cycle, 1 until,
May script in
1 cycle,
a sent.
plus 320, 1 cycle return.
A reserved word is an
Very simple 2 arithmetic operations.
Keywords are reserved
Only 1 register dependency chain.
only in set.
SAL is extremely fast.
Is reserved only inside async functions and modules async.
And it says here,
It can be used as a variable name or statement.
Lee computes the RDI times 5.
Specification uses a combination of
Lee is 1, UOP on modern CPUs.
specify which
Shift arithmetic left, multiply by 64.
all token
Return
word list
is also 2 arithmetic ops plus return. Dependency chain is RDI. REX, REX.
1.1 using parameter
LEA plus shift arithmetic left chain
rules restrict the set of valid identifiers. C13
is slightly longer than just shift arithmetic left plus Lee
7
in routine A.
1.
Possibly negligible.
In summary,
Possibly, because chatbot's like, you know what?
allowed as identifiers and are not keyword.
So here's the result.
So, to
Since both are tiny, pipelined, modern CPUs can retire these in 1 cycle each.
below accept a
The difference is the actual value being shifted and added.
as identifiers.
On some CPUs, adding a small, immediate 320
Identifiers in
may be slightly faster than computing
input
RDI times 5 and LEA, but realistically, this difference is 0 to 1 cycle in practice.
allowed as
Lee for multiplication by a constant like 5 is extremely cheap until UOP fuses it well.
async.
Routine A is slightly simpler and shorter to decode.
The term conditional keyword or
Yes, I win.
sometimes used to refer to the keywords that fall in the last
Routine A, shift arithmetic left,
keyword.
then Lee, RDA plus 320 is slightly simpler and shorter to decode.
Continue
Routine B requires multiplication by 5,
extends false.
Lee, then a shift, so the dependency chain is slightly more complex.
Retry type of
On a CPU, where every cycle counts, routine A is marginally better.
5 1
Micro optimization.
literal sequences.
They've called millions. Of course, it's like a teeny bit. Who cares?
Point in a keyword.
Well, I care because I'm trying to win.
A Unicode escape sequence. An identifier name
So basically,
escape sequence
routine A is marginally better.
named else by spelling it tells you.
I gotta like check. Maybe they don't make the same result.
There are rules in 1.3. 1. One rule out identifiers with the same string value as a reserved word. Note 2 enemies not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13 1 1
Okay, wait a second.
4 1 5 2 1 1 5 5 1 1 5 6 1 and 1.
Alright, they're not exactly the same then.
2.8 punctuators syntax. Punctuator. Optional chaining punctuator. Other punctuator. Optional chaining punctuator. Look ahead decimal digit. Other punctuator. One of, comma, equals. Equals 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 equals
Dang it.
equals 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 plus percent plus plus. And equals plus equals 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 percent equals equals equals
I have count plus 1.
and equals 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 and equals 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 div punctuator equals sign right brace punctuator
To force it to go up 1
2 9 1 null literal syntax
to the next granular level.
null 2024 225
Right, shift 6.
9 2 boolean literal syntax boolean literal true false 2 9 3 numeric literal
Left shift 6.
literal separator, numeric literal, decimal big integer literal non-decimal integer literal, plus sep, non-decimal integer literal, plus sep, big int literal suffix legacy octal integer literal, decimal big integer literal, 0 big int literal suffix,
Wait, do we even need this?
digits, plus sep, up big int literal suffix, non-zero digit numeric literal separator decimal digits, plus sep, big int literal suffix, non-decimal integer literal, sep, binary integer literal sep, octal integer literal sep, hex integer literal sep, big int literal suffix, n decimal integer literal, decimal digits, plus sep, opt exponent part, plus sep, opt, decimal digits, plus sep, exponent part,
Alright, so I'm shifting right. The count.
integer literal,
6 bits. To jump off the bottom.
literal, 0 non-zero digit numeric literal separator opt decimal digits, plus sep, non-octal decimal integer literal, decimal digits, sep, decimal digit sep,
So if I have 64, and I right shift 6.
digits, plus sep, numeric literal separator decimal digit, decimal
The bottom swept off.
1, 2, 3, 4, 5, 6, 7, 8, 9, 26, ECMA International 2024, non-zero digit, 1 of 123,456,789, exponent part, sep, exponent indicator signed integer sep, exponent indicator, 1 of VE, signed integer, sep, decimal digit sep, decimal digits,
Then left shift. Can't I just add 1?
integer literal, sep, 0B binary digit,
So if I multiply that by 1,
binary digit sep, binary digits, sep, binary digit sep, binary digit, plus sep, binary digits, plus sep, numeric literal separated binary digit, 1 of 0, 1, octal integer literal, sep, 0 octal digit sep, 0 octal digit sep, octal digits, sep, octal digit, octal
do you need the second part?
digit, plus sep, octal digits, plus sep, numeric literal separator octal digit, legacy octal integer literal, 0 octal digit, legacy octal integer literal octal digit,
Because count plus 1 means it'll always be 1 greater than.
capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit non-octal decimal integer literal decimal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E,
Right?
capital L, 0 octal digit, capital L,
Because I can literally chop off the 8 bytes,
capital O, C,
like carve them out of the number.
capital L, I, K,
So we can just do RDI plus 1.
C,
Shift left 8.
M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal
Well, because, well, I guess this depends on
international
the size of the type too.
27, hex integer literal, sep, 0x hex digit sep, 0x hex digit sep, hex digits, sep, hex digit sep, hex digit, plus sep, hex digits, plus sep, numeric literal separator hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics. Early errors. Numeric literal, legacy octal integer literal decimal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy 2, 9, 3, 2 static semantics. MV, a numeric literal stands for a value of the number type or the begin type. The MV of
Alright, I gotta stop wasting time on this.
integer literal.
It's not exciting anymore.
Decimal integer literal plus of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal, decimal integer literal
Wait, it says
integer.
it truncates down to the nearest 64 byte per element.
The MV of decimal integer literal.
And it adds 1,
The MV of decimal integer literal, non-zero digit numeric.
which is not the same as rounding up each element
The MV of non
and multiplying by count.
plus the MV of decimal digits, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal digits. Decimal digits is the MV of decimal digits 10 plus the MV of decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer, decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 or of octal.
Why is it showing?
Or of 228.
Huh?
2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in. Legacy octal escape sequence.
Is it
0 or of binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1. The MV of decimal digit.
I hate everything.
Non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit. The MV of decimal digit. 6 or of non-zero digit.
Alright, I'm gonna try 652.
7 or of non-zero digit. The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4. 5 or of hex digit. 5 or of octal digit. 5 is 5. 6 or of hex digit. 6 or of octal digit. 6 is 6. 7 or of hex digit. 7 or of octal digit. 7 is 7. 8 or of non-octal digit. 8 or of hex.
So I want to multiply by like
8 is or of non. 9 or of hex.
7.
9 is.
So 7 times 10.
Or of hex digit. A is 10. The MV of hex digit. B or of hex digit. B is
70.
B of hex digit. C or of hex digit. C is 12. The MV of hex digit. D or of hex digit.
70 left of 6.
Hex digit. E or of hex digit. E is
1 plus 1.
V of hex digit. F or of hex digit.
80.
The MV of binary digits. Binary digits is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits numeric literal separated binary digit is the MV of binary digits plus the MV of binary digit. The MV of octal digits. Octal digit is the MV of octal digits 8 plus
It's 5120.
the MV of octal digits. octal digits numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit, the MV of legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus the MV of octal digit, the MV of non-octal decimal integer literal, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, non-octal digit is the MV.
Alright, so it's 652 times 10, or 7.
Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E,
4564.
M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of non-octal digit, the MV of non-octal decimal integer literal, non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit, the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit is the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of octal digit, the MV of hex digits. Hex digit is the MV of hex digit 16 plus the MV of hex digit, the MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digit 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a begint. It is defined piecewise over the following productions. Numeric literal, decimal literal, return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal, return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal, return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal begint literal suffix, return the begint value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 begint literal suffix 1. Return 0z. Decimal big integer literal, non-zero digit begint literal suffix 1. Return the begint value for the MV of non-zero digit, decimal big integer literal, non-zero digit decimal digits begint literal suffix, non-zero digit numeric literal separator decimal digits begint literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let MV be the MV of non-zero digit 10n plus the MV of decimal digits. Return Z, MV, 2, 9. 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000A, line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character, double string character sopt, single string characters, single string character, single string character sopt, double string character, source character but not one of or all line terminator. LS, PS, escape sequence, line continuation, single string character, source character but not one of or all line terminator. LS, PS, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit. Legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3 octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1, 2, 3, 4 to 7, 1 of 4,567, non-octal decimal escape.
Okay, so 652 times 8
Escape set.
times 7.
Hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex
It's 4564.
hex digit. The definition of the non-terminal hex digit is given in 1293. Source character is defined in 11.1. ECMA International 2024 231. Note 2. LF and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000A. 2. 9. 4. 1 static semantics. Early errors. Escape sequence. Legacy octal escape sequence. Non-octal
Message jump out around 4564
error if the source
to multiple 64.
is strict mode code. Note 1 in non-strict code, this syntax is legacy. 2. 9. 4. 2 static semantic.
Round up.
The syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string value.
Says it's 4608.
Recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below, or in 1293. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters. Double string characters is the string. Concatenation.
That's 5120 minus.
The SV of double string characters. The SV of single string characters. Single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or all line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, LS, is the string value consisting of the code unit 0x2028, line.
512.
The SV of double string character, PS, is the string value consisting of the code unit 0x2029, paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or all line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, LS, is the string value consisting of the code unit 0x2028, Line separator. The SV of single string character PS is the string value consisting of the code unit 0x2029. Paragraph separator. The SV of single string character line continuation is the empty string. The SV of escape sequence 0 is the string value consisting of the code unit 0x0000. Null. The SV of character escape sequence single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character echo. Reading to table 38. Note 2. It is possible
4-5.
to use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error. Function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B0x0008. Backspace. BS. T0x00009. Character tabulation. HT. N0x000A. Line feed. LF V0x000B. Line tabulation. VT F0x000C. Form feed FF R0x000D. Carriage return CR double quote 0x0022 quotation mark apostrophe 0x0027 apostrophe backslash 0x005C. Reverse solidus comma the SV of non-escape character, source character but not one of escape character or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence, legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the MV of legacy octal escape sequence. The SV of non-octal decimal escape sequence 8 is the string value consisting of the code unit 0x00 digit 8. The SV of non-octal decimal escape sequence 9 is the string value consisting of the code unit 0x0039 digit 9. The SV of hex escape sequence X hex digit is the string value consisting of the code unit whose numeric value is the MV of hex escape sequence. The SV of hex 4 digits hex digit is the string value consisting of the code unit whose numeric value is the MV of hex 4 digits. The SV of Unicode escape sequence U code point is the result of performing UTF-16 encode code point on the MV of code point. The SV of template escape sequence 0 is the string value consisting of the code unit 0x0000 null 12 9 4 3 static semantics. MV. The MV of legacy octal escape sequence 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence 0 to 3 octal.
I'm pretty sure the first one works.
82 times.
Why does it say it doesn't?
3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7. The MV of hex escape sequence. X hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0x1000 the MV of the first hex digit plus 0x100 the MVO, F the second hex digit plus 0x10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2.
That's what's adding.
5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2.2.2.1. An implementation may extend the ECMA script regular expression grammar defined in 2.2.2.1. But it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminated but not one of or, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression class, regular expression char, regular expression non-terminated but not one of or, capital R, E, G.
Why is it doing this?
R, capital E, X, P, R.
Wait, no, that part's right.
S,
No, it's not.
O, N.
Is it? What's it doing?
K, S, L, A, S, H, capital S, E.
I don't understand what it's doing.
Regular expression class.
It completely left out the count plus one.
U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital B, A, C, K, S, L, A, S, H, capital S, E, Q, U, regular expression.
So divide by 64 rounding down.
Non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars, empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminated but not one of, or, capital R.
Truncates size type of the nearest multiple of 64.
R, capital E, X, P.
That's not what it's doing.
E, S, S, I, O, N, capital B, A, C.
It's doing count plus one.
A, S, H, capital S, E, Q, U. Note 1. A regular expression literally is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated.
Why is it leaving out the closing parenthesis?
Program evaluate to regular expression objects that never compare as equals to each other even if the two literals contents are identical. A regexp object may also be
Okay, so
new reg
it's right shifting to truncate it.
structure as a function. C to 2.
Then it's multiplying it by count plus one. Then it's shifting it left.
2024.
Chatbot saying it's shifting right to divide down, multiply by 64.
Part char.
Then it multiplies.
5.
That's not the order.
Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression
For fuck's sake.
flags. Return the source text that was recognized as regular expression body 1 2 9 5 2 static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1 2 9 16.
Okay, now I think it's doing it right.
Syntax. Templar. no
right shift 6,
template head no substitution template
multiply by count plus 1,
template corrector
shift left 6.
substitution tail
This effectively restores the value to a multiple of 64,
9
but ignores the remainder from truncation.
template characters
Add 1, left shift 6,
note to
adds 64 bytes to the result.
empty
This is outside all parentheses, so it's added after all previous computation.
single line comment
Size of t, right shift 6, floor division by 6,
start
count plus 1, add 1 to count,
200 and
multiply the 2,
character
count plus 1 in truncated units,
sequence
shift left, multiply by 64,
continuation
add 64,
source character but
compute truncated 64 byte blocks per element, multiply by count plus 1, scale back to bytes, add 64 bytes.
X escape sequence Unicode escape sequence not escape sequence 0 decimal
Sure, draw a diagram.
look ahead hex digit X hex digit look ahead hex digit U look ahead hex digit look ahead U hex digit look ahead hex digit U hex digit look ahead hex digit U hex digit hex digit look ahead hex digit U look ahead hex digit U not code point look ahead hex digit U code point look ahead hex digit look ahead not code point hex digits sep but only if MV of hex digits 0x10ff code point hex digits sep but only if MV of hex digits 0x10ff. Note template substitution tail is used by the input element template tail alternative lexical goal 1-2
So I'm saying, draw a diagram,
semantics
and I'm saying, and also tell me if that routine will correctly round up larger than needed, so it won't ever spill while being 64-bit byte aligned.
type TV is used to construct the indexed components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code unit, S, of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the
There we go. Does it always round up safely?
is
Yes, with caveats.
TV of template characters,
For less than equal to 64, always safe, just over allocates a bit.
find or the
For any size of type that is not a multiple of 64,
it is
the truncation from right shift 6 loses remainder.
TV of
This is why you add plus 64 at the end.
source
It's meant to cover the loss of space.
terminator is the result of performing
This works as long as remainder is a multiple,
the TV
as long as the remainder times count
consisting of the code unit 0x00
is less than or equal to 64.
template character. Template escape sequence is the SV of template escape sequence. The TV of template character, not escape sequence, is undefined. The TV of template character, line terminator sequence is the TRV of line terminator sequence. 236. Copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequence is the empty string 1 2 9 6 2 static semantics. TRV, the syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is
Size of type is 100 bytes.
$, is the empty string. The TRV of template middle, $, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $, or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $sign is the string value consisting of the code unit 0x0024. $sign. The TRV of template character. Template escape sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of template escape sequence. The TRV of template character, not escape sequence is the string concatenation of the code unit 0x005C, reverse solidus, and the TRV of not escape sequence. The TRV of template escape sequence. 0 is the string value consisting of the code unit 0x0030. Digit 0. The TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0x0030. Digit 0. And the TRV of decimal digit. The TRV of not escape sequence. X. Look ahead hex digit is the string value consisting of the code unit 0x0078. Latin small letter x. The TRV of not escape sequence. X hex digit. Look ahead hex digit is the string concatenation of the code unit 0x0078. Latin small letter x. And the TRV of hex digit. The TRV of not escape sequence. U. Look ahead hex digit. Look ahead.
Okay, so it doesn't work then.
The code unit.
Dang it.
0075. Latin small letter U. The TRV of not escape sequence. U hex digit. Look ahead hex digit is the string concatenation of the code unit 0x0075. Latin small letter U. And the TRV of hex digit. The TRV of not escape sequence. U hex digit. Look ahead hex digit is the string concatenation of the code unit 0x0075. Latin small letter U. The TRV of the first hex digit, and the TRV of the second hex digit. The TRV of not escape sequence. U hex digit. Look ahead hex digit is the string concatenation of the code unit 0x0075. Latin small letter U. The TRV of the first hex digit. The TRV of the second hex digit. And D. The TRV of the third hex digit. The TRV of not escape sequence. U. Look ahead hex digit is the string concatenation of the code unit 0x0075. Latin small letter U. And the code unit 0x007b. Left curly bracket. The TRV of not escape sequence. U. Not code point. Look ahead hex digit is the string concatenation of the code unit 0x0075. Latin small letter U. The code unit 0x007b. Left curly bracket. And the TRV of not code point. The TRV of not escape sequence. U. Code point. Look ahead hex digit. Look ahead is the string concatenation of the code unit 0x0075.
What if I multiply the count by 6?
07b.
Yeah, I'm gonna give up in a second.
And the TRV of code point. The TRV of decimal digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character. 1 of BFNRTV is the result of performing.
Yeah, this isn't right.
Encode code point on the single code point matched by this production. The TRV of hex escape sequence. X hex digit is the string concatenation of the code unit 0x0078. Latin small letter x. The TRV of the first hex digit. And the TRV of the second hex digit. The TRV of Unicode escape sequence. U hex 4 digits is the string concatenation of the code unit 0x0075. Latin small letter U. And the TRV of hex 4 digits. The TRV of Unicode escape sequence. U.
It massively overallocates.
0x0.
So it says you're safe, but wasteful.
Letter U.
Alright, but does it say any instructions?
007b. Left curly bracket.
I just want to get something that's faster than Jetbot. If it's a massive waste, I don't care.
And the code unit 0x007d. Right curly bracket. The TRV of
Just to get something that's faster.
hex digit.
All I'm trying to do.
Is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit, one of 0, 1, 2, 3, 4, 5, 6, 7, 8.
Oh, I win.
EF is the result of
So it's gonna allocate
point on the
way more space than needs,
production. The TRV of line continuation, line
but it's faster.
string concatenation of the code unit 0x005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence, LF, is the string value consisting of the code unit 0x000A line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0x000A line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0x2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0x2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0x000A line feed. 2.10 automatic semicolon insertion. Most DCMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are three basic rules of semicolon insertion. When, as the source text is parsed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be parsed as the terminating semicolon of a do-while statement. 1.4.7.2 When, as this
Back to this one.
left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is parsed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production. And therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence. 38 ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be parsed as an empty statement or if that semicolon would become one of the two semicolons in the header of a for statement. C14.7.4.
How does this work?
Only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here. Left-hand side expression yield await. No line terminator here. Continue statement, yield, await. Continue, no line terminate or here. Label identifier yield await. Break statement, yield, await. Break, no line terminator here. Label identifier yield await. Return statement, yield, await. Return, no line terminator here. Expression, plus in yield await. Throw statement, yield, await. Throw, no line terminator here. Expression, plus in yield await, yield expression, in await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await, arrow function, in, yield, await, arrow parameters yield await, no line terminator here, equals, concise body in, async function declaration, yield, await, default, async, no line terminator here, function,
So 100.
yield await, formal parameters, yield, plus await, async function body, plus default, async, no line terminator here, function, formal parameters, yield, plus
Gives me 1.
async function body,
Count 3 plus 1 is 4.
async, no line terminator here,
Times 64.
yield, plus await, opt, formal parameters,
256.
async function body, async method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, yield, plus await, async function body, async generator declaration, yield, await, default, async, no line terminator here, function binding identifier yield await,
Plus 64 gives me 320.
plus await, async generator body, plus default, async, no line terminator here, function, formal parameters, plus yield, plus await, async generator body, async generator expression, async, no line terminator here, function binding identifier, plus yield, plus await, opt, formal parameters, plus yield, plus await,
I'll grade back to what I had before.
async generator method, yield, await, async, no line terminator here, class element name yield await, unique formal parameters, plus yield, plus await, async generator body, async arrow function, in, yield, await, async, no line terminator here, async arrow binding identifier yield, no line terminator here, equals, async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, no line terminator here, equals, async concise body in, ECMA International 2024 239, async arrowhead, async, no line terminator here, arrow formal parameters, yield, plus await. The practical effect of these restricted productions is as follows. When a ++ token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the ++ token, then a semicolon is automatically inserted before the ++ token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield
Alright, gotta keep up in a second. See what we do. I don't think I can beat it.
are followed by a line terminator before it equals token
That's probably the best way to do it.
automatically inserted and the punctuator
I'm wasting time at this point.
token is followed terminator before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is, a postfix ++ or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter, s, and its equals, should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2. 1 0. 2 examples of automatic semicolon insertion. This section is non-normative. The source. 12. 3 is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast,
Alright, so if I
3 is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMA script sentence. The source 4, A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, A plus B, is transformed by automatic semicolon insertion into the following, return, A plus B. The source, A equals B plus C, is transformed by automatic semicolon insertion into the following, A equals B plus C. The source, if B, else C equals D, is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be parsed as an empty statement, the source, A equals B plus C, D plus C print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call, A equals B plus C, D plus C print, in the circumstance that an assignment statement must begin with a left parenthesis. It is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2. 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression A plus B is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus is not treated as a postfix operator applying to the variable B, because a line terminator occurs between B and plus. ECMA International 2024 241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2. 1, 0. 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending an expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tagged template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator, for example if the regexp has flags. 2. 1, 0. 3. 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here, in this version of VCMA script. 2, 1, 0, 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions. 15.8, with relation to function definitions. 15.2, 42, ECMA intern, National 2024, 13 ECMA script language. Expressions. 3.1 identifiers syntax. Identifier reference. Yield, await. Identifier, yield, yield, await, await. Binding identifier, yield, await. Identifier, yield, await. Label identifier, yield, await. Identifier, yield, yield, await, await. Identifier, identifier name but not reserved word. 3, 1 static semantics. Early errors. Binding identifier. Identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and a string value of identifier as either arguments or eval. Identifier reference. Yield binding identifier. Yield label identifier. Yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference. Await binding identifier. Await label identifier. Await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier. Yield. Await. Yield. It is a syntax error if this production has a yield parameter. Binding identifier. Yield. Await. Await. ECMA International 2024 243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below, to prohibit automatic semicolon insertion in cases such as let await 0, comma. It is a syntax error if this production has an await parameter. Identifier reference. Yield, await. Identifier binding identifier. Yield, await. Identifier label identifier. Yield, await. Identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3, 1, 2 static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions. Identifier name. Identifier start. Identifier name. Identifier part. Let text on escaped be identifier code points of identifier name. Return code points to string. Text on escaped. Identifier reference. Yield binding identifier. Yield label identifier. Yield. Return yield. Identifier reference. Await binding identifier. Await label identifier. Await. Return await. Identifier. Identifier name but not reserved word. Return the string value of identifier name. Private identifier. Identifier name. Return the string concatenation of 0x0023. Number, sign, and the string value of identifier name. Module export name. String literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024 1.3.1.3 Runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier. Identifier reference. Yield. Return. Resolve binding. Yield. Identifier reference. Await. Return. Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression, yield, await. This, identifier reference yield await. Literal, array literal yield await. Object literal yield await. Function expression, class expression yield await. Generator expression, async function expression, async generator expression, regular expression literal. Template literal yield await. Tagged, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A.
Alright, maybe this will work. It's not gonna work. Oh well.
Yield await, expression, plus in yield await, dart. Binding identifier yield await, dart. Binding pattern yield await, expression, plus in yield await. Binding identifier yield await, expression, plus in yield await. Binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024-245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E
Huh.
I
I think I'm gonna give up.
D, capital E X P
Chatbot might win this one.
S I O N
That's actually a simpler way.
N, yield await. The interpret
I can't think of any way.
O V E R
Dang it.
P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, is refined using the following grammar. Parenthesized expression, yield, await, expression, plus in yield await.
Alright, maybe we can rewrite it.
1 Thetis keyword. 3, 2, 1. 1 Runtime semantics. Evaluation. Primary expression. This. Return. Resolve this binding. 3, 2. 2 Identifier reference. See 13.1 for identifier reference 1 3. 2, 3 literals. Syntax. Literal. Null literal. Boolean literal. Numeric literal. String literal. 3, 2, 3. 1 Runtime semantics. Evaluation, literal, null literal 1. Return null literal, Boolean literal. If Boolean literal is the token false, return false. If Boolean literal is the token true, return true. Literal, numeric literal. Return the numeric value of numeric literal as defined in 1 2 9 3. Literal, string literal. Return the SV of string literal as defined in 1 2 9 4 2 46. ECMA International 2024 132 4 Array initializer. Array elements may be elided at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal, yield, await. Elision-opt. Element list yield await. Element list yield await. Elision-opt. Element list. Yield, await. Elision-opt assignment expression, plus in yield await. Elision-opt spread element yield await. Element list yield await. Elision-opt assignment expression, plus in yield await. element list yield await. Elision not spread element yield await. Elision spread element yield await. Dart assignment expression plus in yield await 1 3 2 4 1 runtime semantics. Array accumulation. The syntax directed operation array accumulation takes arguments an array,
Oh man, same thing.
and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232 1. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Let init result be evaluation of assignment expression. Let init value be get value init result. Perform. Create data property or throw array to string next index init value return next index plus 1. Note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array
Wait.
enclosed in square brackets.
This might not work.
Literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision not spread element. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision not assignment expression. Set next index to array accumulation of element list with arguments array and next index. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Let init result be evaluation of assignment expression. Let init value be get value init result. Perform. Create data property or throw array to string next index init value return next index plus 1. Element list.
Alright, try this.
Elision not spread element. Capital S at next index to array accumulation of element list with arguments array and next index. If elision is present, then a set next index to array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be evaluation of assignment expression. Let spread obj be get value spread ref. Let iterator record be get iterator spread obj.
I'm close.
Repeat. A let next be iterator step value iterator record. B if next is done return next index. C perform. Create data property or throw array to string next index. Next, dset next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2,
What if we do 2?
2. Runtime semantics. Evaluation. Array literal. Elision opt. Let array be. Array create. 0. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. Let array be. Array create. 0. Perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision or
I like how chatbot's like, just do this. Just do it this way.
array accumulation of element list with arguments array and 0. 48. ECMA International 2024 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property
My chatbot changed its output.
definition list. Yield await. Property definition list. Yield. await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition yield await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression plus in yield await. Method definition yield await. Dart. Assignment expression plus in yield await. Property name yield await. Literal property name. Computed property name yield await.
Yeah, it's worse.
Identifier name. String literal numeric literal. Computed property name yield await. Assignment expression plus in yield await. Cover initialized name yield await. Identifier reference yield await. Initializer plus in yield await. Initializer in yield await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals, they are evaluated each time the object initializer is evaluated. Copyright sign, ECMA International 2024-249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In, used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed.
Alright, this, right shift 6, left shift 6.
2, 5, 2 static semantics is
We'll get the number,
the syntax directed
but chop off parts.
property key takes no arguments and returns a boolean. It is defined
There's no way to do it.
productions. Property name, literal property name, return false. Property name, computed property name, return true. Addition to describing an actual object, initialize the object.
What if I just do this?
250. ECMA International 2024. Note 1 this production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note does not include property names defined using a computed property name. 1, 3, 2, 5, 3 static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5, 4 runtime semantics. Evaluation. Object literal. Return ordinary object create. Object prototype object literal. Property definition list. Property definition list. Let
I give up.
create.
There's no way.
Prototype perform. Property definition evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return to string. NBR. Computed property name. Assignment expression. Let exp value be. Evaluation of assignment expression. Let prop name be. Get value. Exp value. Return to property key. Prop name. 3, 2, 5. 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition perform. Property definition evaluation of property definition list with argument object perform. Property
I think this is probably more instructions, so.
object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let exp value be. Evaluation of assignment expression. Let from value be. Get value. Exp value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier. Prop name be string.
I didn't piece it yet.
Fire reference. Let exp value be.
I don't think this would be faster.
Let prop value be. Get value. Exp value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be. Evaluation of property name. If this property definition is contained,
Man.
evaluated for JSON pars. See step 7 of JSON pars.
Hey, Jetbot.
Proto setter be false. Else if prop key is proto and is computed property key of property name is false. Then
So can't that be the same as this?
a let is proto setter be false. If is anonymous function definition, assignment expression, is true and is proto setter is false. Then a let prop value be. Named evaluation of assignment expression with argument prop key. Else a let exp value ref.
Oh, it is.
Evaluation of assignment expression. B let prop value be. Get value. Exp value ref. If is proto setter is true, then
If I shift to last.
or prop value is null, then I perform object. Prop value be return and unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop key. Prop value 0. Return.
Huh.
Method definition. Perform. Method definition evaluation of method definition with arguments object and true. Return unused.
REX times RDI.
Defining expressions. C15.2 for primary expression. Function expression. C15.5 for primary
The leads can be faster.
expression. C15.7 for primary expression. Class expression. C15.8 for
I can't think of any way to beat it.
in function expression. C15.6 for primary expression. A synth generator expression. 52. Copyright sign. ECMA International 2024 132 7 Regular Expression Literal Syntax C12 9 5 3 2 7 1 Static Semantics Early Errors Primary Expression Regular Expression Literal. It is a syntax error if capital
We'll actually make a truth table.
V A L I D capital R E G U L A R capital E X P R E S S I O N capital L I T E R A regular expression literal is false. 3 2 7 2 Static semantics capital I S capital V
It's only giving me the two that I told it, basically.
R E G U L A R capital E X P R E S S I O N capital L I T E R A literal. The abstract operation capital I S capital V A L I D capital R E G U L A R capital E X P R E S S I O N capital L I T E R A takes argument literal, a regular expression literal parse node, and returns a Boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y. Or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, then A let string value be code points to string, pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern, pattern text, U, V. If parse result is a parse node, return true.
Oh man.
3 2 7 3 Runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return. regexp create, pattern, flags. 3 2 8 Template literal syntax. Template literal, yield, await, tagged. No substitution template. Substitution template yield await tagged. Substitution template, yield, await, tagged. Template head expression, plus in yield await. Template spans yield await tagged. Template spans, yield, await, tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list, yield, await, tagged. Template middle.
Yeah, this is not right.
Template middle list yield await tagged. Template middle expression, plus in yield await. 3 2 8 1 Static semantics. Early errors. Template literal, yield, await, tagged. No substitution template. It is a syntax error if the tagged
Nope.
set and no substitution template contains not escape sequence template.
Alright, so I found whatever.
Substitution template
This is better.
syntax error if the
Matchup. Is this better than...
false is greater than or equal to 200
Is this more solid than your output,
yield await.
arithmetic wise?
Template head expression, plus in yield await. Template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans, yield, await, tagged. Template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list, yield, await, tagged template middle expression plus in yield await template middle list yield await tagged template.
So message chatbot, is this more solid than what you gave me arithmetic wise?
Parameter was not set and template middle contains not escape sequence 3, 2, 8, 2 static semantics, template strings, the syntax directed
They'll both compile to the same thing in C.
or a boolean and returns a list of either strings or undefined. It is defined piecewise over the following productions: template literal, no substitution template, return template string, no substitution template, raw, substitution template, template head expression template spans, let head be template string, template head, raw, let tail be template strings of template spans with argument raw, return the list concatenation of head and tail, template spans, template tail, return template string, template tail, raw, template spans, template.
It says
Template strings of template.
slightly less intuitive.
Templates.
Very expect, round up to multiple 64.
Turn the list concatenation of middle and tail.
Same for overflows.
More international
Slightly fewer operations in theory.
list.
2 shifts versus shift plus multiply.
String. Template middle.
It's not even accounting for
Template middle.
slightly more readable, same compiler output.
Strings of template middle list with argument.
It just won't sound right.
Template string. Template middle. Raw. Return the list concatenation of front and last.
Alright, I don't know.
2, 8.
This is better
Antics. Template.
than what chatbot had.
Template token. Raw.
That was not worth it. Not at all. Man. Alright, last attempt. There has to be. Oh, same issue as before. It's not gonna work. if I... I thought I tried this before already. Oh, wait, I typed it wrong. Oh, man. Fuck this stupid compiler. Fuck you, compiler. Damn it. I can't win. When it's a compiler. Because it breaks down to the same fucking thing. Okay, I really gotta stop. I'm just so close. Wait. What if I left shift 7 to align it a little bit larger? This is it. I got it. Jetbot can suck a chode. I made a quad. Just waste more space? Yes. But if it's faster, instruction-wise, please, please, please. There's more waste this way, but I can cut out one step. Due to overallocation, 64 byte aligned, minimal in arithmetic, overallocates unpredictably and doesn't handle arbitrary size s cleanly. This is not a good formula. It may appear safe in some cases, but is arbitrary and wasteful. The correct minimal branch remains. Both guarantee. Okay, so this still truncates s can spill if count is small, but s is greater than 64 and you rely on precise sizing. It doubles the intended allocation. Hold on, I'll do this on purpose. This way I'll have double the amount allocated before I have to actually double it. It makes so much sense. So I win. No, it's not accidentally safe. I'm intentionally allocating way more than I need to avoid this +1 here. Because if I double the size, a number plus, like, any number plus itself is going to overflow. So like, if it's 56 plus 56 whatever, alright, it's like whatever this number is, it's gonna set this bit. If I add 120 to it, overflow. Man, I win. Yes, yes, I win. Chatbot can suck a fucking quad. Alright, so here's what Chatbot says. Chatbot says, I'm wrong. Okay? It says, sure, let's carefully construct a counterexample where your formula underallocates. It says, recall the formula. Pick a type size that is just over a multiple of 64. It says S right shift 6 equals 2 truncated multiplied by count 2. It says compute the needed size precisely. It says weight allocated 256 000 000. Actually enough. Jeppa says, need to push truncation a bit further. Dang, I forgot to switch the screen. Alright, so I told Chatbot, show me one time where it ends up being not large enough. And it said, sure, let's carefully construct a counterexample. paste this into that online text-to-speech. Alright, so I win, chatbot loses, because I'm always gonna win, because chatbot sucks.
Show me one time where it ends up being not large enough. ChatGPT said, sure, let's carefully construct a counterexample where your formula, Alex size A equals CNT 7, underallocates. Step 1, recall the formula. Alex size A equals floor 64.
Come on. So like right here, whatever, like I just said a second ago, it says, because left shift 7 multiplies the truncated units by 128 bytes, it is always at least double per element allocation. So in practice, this formula never underallocates. It just wastes a huge amount. But it's not a waste if I'm planning to double the size of the allocation every time the vector reaches the top and I have to make more memory. So if instead I'm actually just doubling the amount of memory allocated ahead of time, which doesn't waste memory, because technically I might need to resize it to a larger size later by doubling it. So chatbot came to like the same conclusion. I want to like run a loop to test it to be sure. But technically, it should always be, I think it'll like hit exactly the alignment amount at some point. But it would like be kissing just about, not large enough, but it'd be like the exact same size at some point. So like kiss it and then like be too big for allocating again. So it gets really, really close, but we'll never actually go over. I think. I want to double check. I had to make a loop and check. But if it's true, then I win. I think it's true. I like how chatbot argues that like it doesn't matter if it works, you're still wrong. Because I win. Chatbot's stupid. Alright, see if this works. Alright, so here.
Sure, let's carefully construct a counterexample where your formula, Alex size A equals CNT 7, underallocates. Step 1, recall the formula. Alex size A Alex size A equals CNT, 128. S6 equals floor. CNT equals number of elements. 7 equals multiply by 128 bytes. Step 2. Pick a type size that is just over a multiple of 64. Let S equals 130 bytes. CNT equals 1 billion. S6 equals floor equals 2. Multiply by CNT. 2 1 billion is equal to 2 billion units. 7 is equal to 2 billion 128 is equal to 256 billion bytes. Step 3. Compute the needed size precisely. Needed equals SCNT equals 131 billion is equal to 130 billion bytes. Wait, allocated equals 256 billion, actually enough. Need to push truncation further. Step 4. Smaller s that truncates more proportionally. Let s equals 65 bytes. CNT equals 2. S6 equals floor equals 1. Multiply by CNT. 1 2 is equal to 2. 7 to 128 is equal to 256 bytes. Needed. 65 2 is equal to 130 bytes enough. Still enough. Step 5. Try a slightly over multiple of 64 with huge CNT. S equals 65 bytes. CNT equals 1 billion. S6 is equal to 1. Multiply by CNT. 1 billion is equal to 1 billion. 7 is equal to 1 billion 128 is equal to 128 billion bytes. Needed. 65 1 billion is equal to 65 billion still enough. Step 6. Observation. Because 7 multiplies the truncated units by 128 bytes, it always at least doubles the per element allocation. So in practice, this formula never underallocates. It just wastes a huge amount. Conclusion. This formula won't underallocate. The 7 is so large it covers the lost remainder. But it massively overallocates, and the amount depends on S, sometimes double, sometimes more. It is not minimal or mathematically clean, even if it's technically safe.
So, I fucking win. Chatbot sucks. Because it's less instructions. Right here. It's just a shift left 9 compared to a super expensive Lee. Then a shift of arithmetic left 6. At least for the size T. I'm gonna ask Chatbot. Which of these is faster, assembly-wise? If the size T is different, the formula will change. But whatever. I'm just like, this is it, whatever. But I'm comparing. I'm asking Chatbot, which of these will execute faster, be more performant? And Chatbot says, shift left, a cycle integer on modern x86. Move is also one cycle, paired with SAL. In out-of-order execution, two instructions, extremely cheap. Lee RAX, RDI plus RDI times 4. Lee is very fast with OLU, but slightly more complex to move. Shift to arithmetic left, multiply by 64. Two instructions as well, however, this computes RDI times 320, not RDI times 512. So arithmetic results different. You need RDI times 8 instead if you want 512. Both shift arithmetic left and Lee are extremely fast. On modern CPUs, move plus SAL is slightly simpler, fewer internal UOPs. Lee has microfusion, but still more complex. So option A wins by a hair. It wins by a hair. Just a hair. But I win. My JavaScript engine, it wins by like a head full of hairs compared to Chrome. Chrome V8 is so slow. My JavaScript engine is a head full of hairs. It wins by a head full of hairs. Right here, I win by a hair. But my engine, a head full of hairs. I'm gonna win. And chatbot sucks.
Template middle list. Template middle expression 1. Return template string. Template middle. Raw. Template middle list. Template middle list. Template middle expression. Let front be template strings of template middle list with argument raw. Let last be template string. Template middle. Raw. Return the list concatenation of front and last. 3, 2, 8. 3 static semantics. Template string. Template token. Raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called if raw is true. Then, a let string be the TRV of template token, else, a let string be the TV of template token, return string. 3, 2, 8. 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called let realm be the current realm record. Let template registry be realm. For each element of template registry, do if is the same parse node as template literal, then returnee. Let raw strings be template strings of template literal with argument true. Assert. Raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert. Count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0 2. Repeat. While index count a let prop be to string index b let cook value be cook strings index c perform. Define property or throw template prop property descriptor cook value writable false true false. D let raw value be the string value raw strings index e perform. Define property or throw raw obj prop property descriptor raw value false true false. F set index to index plus 1 3. Perform. Set integrity level raw obj frozen 4. Perform. Define property or throw template raw property descriptor raw obj false enumerable false false 5. Perform. Set integrity level template frozen 6. Append the record template literal template to realm. 7. Return template. Note this operation returns undefined if OR is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024-255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the EV. Allocation of tagged templates. 1, 3, 2, 8, 6. The template objects are frozen and the same template object is used each time a specific tagged template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMA script code. 1, 3, 2, 8, 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let preceding be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3, 2, 8. 6. Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value-alike string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1, 2, 9, 6. Template spans. Template middle list. Template tail. Let it be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2 runtime semantics. Evaluation, primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Let X be the parenthesized expression that is covered by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. Return. Evaluation of expa, parenthesized expression, return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type-off may be applied to parenthesized expressions. ECMA International 2024 257. 13.3 Left-hand side expression syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await, plus tagged super property yield await, meter property, new member expression yield await, arguments yield await, member expression yield await, private identifier super property yield await, super expression plus in yield await, super identifier name meter property. New target, import meter, new target, import meter, new expression, yield, await, member expression yield await, new expression yield await, call expression, yield, await, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression plus in yield await, call expression yield await, identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await, private identifier, super call, yield, await, super arguments yield await, import call, yield, await, import, assignment expression, plus in yield await, arguments, yield, await, argument list yield await, 58, ECMA International 2024, argument list, yield, await, assignment expression, plus in yield await, dart, assignment expression, plus in yield await, argument list yield await, assignment expression, plus in yield await, argument list yield await, assignment expression, plus in yield await, optional expression, yield, await, member expression yield await, optional chain yield await, call expression yield await, optional chain yield await, optional expressi, on yield await, optional chain yield await, optional chain, yield, await, arguments yield await, expression, plus in yield await, identifier name, template literal yield await, plus tagged, private identifier, optional chain yield await, arguments yield await, optional chain yield await, expression, plus in yield await, optional chain yield await, identifier name, optional chain yield await, template literal yield await, plus tagged, optional chain yield await, private identifier, left-hand side expression, yield, await, new expression yield await, call expression yield await, Optional expression yield await. Supplemental syntax. When processing an instance of the production, call expression, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. The interpretation of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, is refined using the following grammar. Call member expression, yield, await. Member expression yield await. Arguments yield await. 3, 3, 1 static semantics. 3, 3, 1, 1 static semantics. Early errors. Optional chain. Template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A.B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining. A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meter. It is a syntax error if the syntactic goal symbol is not module 1.3. 3. 2 property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name, is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name, is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3, 3, 2, 1 runtime semantics. Evaluation, member expression, expression. Let base reference be. Evaluation of member expression. Let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, base value, expression, strict. 60. ECMA International 2024. Member expression, identifier name. Let base reference be. Evaluation of member expression. Let base value be. Get value, base reference. If the source text match D by this member expression is strict mode code, let strict be true, else let strict be false. Return, capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, base value, identifier name, strict. Member expression, private identifier. Let base reference be. Evaluation of member expression. Let base value be. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference, base value, field name string. Call expression, expression. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name let base reference be evaluation of call expression let base value be get value base reference if the source text matched by this call expression is strict mode code let strict be true else let strict be false.
Let the records show
L U A T E
that I have beaten chatbot
E
at micro optimization
A
every single time. I have never lost.
W I
The most pointless of all optimization,
N
micro optimization.
name
Never lost.
expression
Not once to chatbot
identifier let
because chatbot sucks.
capital A C C E S S cap
I can micro optimize circles around chatbot.
R base value
Imagine how much I can micro optimize in 2 years
P R O P
when running a JavaScript engine from scratch.
A
It's a whole lot of micro optimization.
S capital
All I gotta do is update my engine
capital E
to meet the ECMA 262
value
to add the rest of the mechanics
language value expression an expression parse node
to go from page 1 to page 816.
animal completion containing a reference record
And this is like a stupid little thing,
following steps when called let
but this is a big thing.
evaluation of
It's a shitload faster than Chrome.
you
Chrome V8.
let property key be to property key
It will end up being slightly slower when meet the standard,
key
which is why I'm gonna make my own standard that's like not 32-bit,
capital E
because 32-bit is like 20 years ago. It's 64-bit and 512-bit
P E
or 524-bit, 512. I don't know, whatever.
C C
Yeah, I don't know, whatever.
W
I gotta stop arguing with chatbot
capital I D
because I will always win.
base value identify name strict the abstract operation
Except I gotta get this stupid freaking
A L U
vector thing done.
E capital P R O P E R T Y capital A
Alright, so I'm trying to finish this up now.
E S S capital W I T H capital I D E N takes arguments base value an ECMA script
I need some music.
identify name an identify name parse node and strict a boolean and returns a reference record. It performs the following steps when called let property name string be string value of identify name return the reference record base value property name string strict empty ECMA International 2024 261 133 5 Venue operator 3 3 5 1 runtime semantics evaluation new expression new expression return evaluate new expression empty member expression new member expression arguments 1 return evaluate new member expression arguments 3 3 5 1 1. Evaluate new. Construct expa. Arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or a member expression parse node, and arguments, empty or in arguments parse node, and returns either a normal completion containing an ECMA script language evalu or an abrupt completion. It performs the following steps when called let ref be. Evaluation of construct expa. Let construct to be. Get value, ref. If arguments is empty, then a let arg list be a new empty list for. Else, a let arg list be. Argument list evaluation of arguments. If is constructor is false. Throw a type error exception. Return constructor arg list 3 6 function calls 3 6 1 runtime semantics. Evaluation call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let expa be the call member expression that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Let member expa be the member expression of expa. Let arguments be the arguments of expa. Let ref be. Evaluation of member expa. Let func be. Get value, ref. If ref is a reference record, is property reference, ref. And ref is eval, then a if same value. Func, %eval % is true, then
Chrome is like Chrome V8. It's like so slow.
if I
Google's literally gonna be like, what the fuck are we gonna do?
would be
It's so much faster. Holy fuck.
if the source
It's gonna be the funniest shit ever.
be true. Otherwise let
It's so fucking fast.
perform eval
And take the whole fucking internet.
true. Let this call be this call express
In the 1%, there'll be no more 1%.
evaluate
Everybody is gonna be part of the percent.
tail
Everyone.
an evaluation that
It'll be a totally fair playing field.
call expression up
No more gatekeeping.
of call expression. Let func be
It'll be awesome.
ref
I gotta get this shit done.
expression. Let tail call be is in tail position. This call return evaluate call func ref arguments tail call 62 ECMA International 2024 133 2 evaluate call func ref arguments tail position. The abstract operation evaluate call takes arguments func an ECMA script language value ref an ECMA script language value or a reference record arguments a parse node and tail position a boolean and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called if ref is a reference record, then a if is property reference, ref is true, then I let this value be get this value, ref be else, I let ref env be ref 2. Assert, ref env is an environment record 3. Let this value be ref env with base object, else, a let this value be undefined, let arg list be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return call func this value arg list 3 7 decimal per keyword 3 7 1 runtime semantics evaluation super property super expression. Let env be get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value property name reference. Let property key be to property key, property name value. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. Return, make super property reference, actual this, property key, strict, super property, super, identifier name. Let env beget this environment. Let actual this be env get this binding. Let property key be string value of identifier name. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. Return, make super property reference, actual this, property key, strict, super call, super arguments. Let new target beget new target. Assert, new target is an object. Let func beget super constructor. Let arglist be argument list evaluation of arguments. If is constructor, func is false, throw a type error exception. Let result be construct, func, arglist, new target. Let this beget this environment. Perform this bind this value. Result. Let f be this 0. Assert, f is an ECMA script function object. 1. Perform, initialize instance elements. Result, f. 2. Return result. ECMA International 2024 263 133 7. To get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMA script language value. It performs the following steps when called. Let envrec beget this environment. Assert, envrec is a function environment record. Let active function be envrec. Assert, active function is an ECMA script function object. Let superconstructor be active function. Return superconstructor. 3. 7. 3 make super property reference. Actual this, property key, strict. The abstract operation makes super property reference takes arguments actual this, an ECMA script language value, property key, a property key, and strict, a boolean, and returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env beget this environment. Assert, env has super binding, is true. Let base value be env get super base. Return the reference record, base value, property key, strict, this value, actual this. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3 8. 1 runtime semantics. Argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMA script language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. A let next be. Iterator step value. Iterator record. B if next is done. Return list. C append next to list. Argument list. Argument list. Assignment expression. 1. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. A let next be. Iterator step value. Iterator record. B if next is done. Return preceding args. C append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let site obj beget template object. Template literal. Return site obj. Template literal. substitution template. Let template literal be this template literal. Let site obj beget template object. Template literal. Let remaining be. Argument list evaluation of substitution template. Return the list concatenation of site obj and remaining. Substitution template. Template head expression template spans. Let first subref be. Evaluation of expression. Let first sub be. Get value. First subref. Let rest sub be. Substitution evaluation of template spans. Assert. Rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3, 3, 9 optional chains. 3, 3, 9, 1 runtime semantics. Evaluation, optional expression, member expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value, base reference. If base value is either undefined or null, then a returned undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value, base reference. If base value is either undefined or null, then a returned undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the token. ECMA International 2024-265. Optional expression. Optional expression optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value, base reference. If base value is either undefined or null, then a returned undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. 3, 3, 9, 2 runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMA script language value, and base reference, an ECMA script language value or a reference record, and returns either a normal completion containing either an ECMA script language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be is in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, base value, expression, strict, optional chain. Identifier name. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict, optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference, base value, field name string, optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value, new reference. Let this chain be this optional chain. Let tail call be is in tail position. This chain. Return. Evaluate call. New value, new reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value, new reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R new value expression strict optional chain identifier name let optional chain be optional chain let new reference be chain evaluation of optional chain with arguments base value and base reference let new value be get value new reference if the source text matched by this optional chain is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N new value identifier name strict 66 ECMA International 2024 optional chain private identifier let optional chain be optional chain let new reference be chain evaluation of optional chain with arguments base value and base reference let new value be get value new reference let field name string be the string value of private identifier return make private reference new value field name string the 3rd of March 2010 import calls 3.3.1.0.1 runtime semantics evaluation import call import assignment expression let referrer be get active script for module if referrer is null set referrer to the current realm record let argref be evaluation of assignment expression let specifier be get value argref let promise capability be new promise capability %promise let specifier string be completion to string specifier if abrupt reject promise specifier string promise capability perform host load imported module referrer specifier string empty promise capability return promise capability 3.3.1.0.1 continue dynamic import promise capability module completion the abstract operation continue dynamic import takes arguments promise capability a promise capability record and module completion either a normal completion containing a module record or a throw completion and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call is appropriate. It performs the following steps when called. If module completion is an abrupt completion, then a perform call promise capability undefined module completion be return unused let module be module completion let load promise be module load requested modules let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined reason be return unused let on rejected be create built-in function rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and on rejected and performs the following steps when called. A. Let link be completion module link. B. If link is an abrupt completion, then I perform call promise capability undefined link. 2. Return unused. C. Let evaluate promise be module evaluate. D. Let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I. Let namespace be get module namespace module. 2. Perform call promise capability undefined namespace. 3. Return unused. A. Let unfulfilled be create built-in function fulfilled closure 0. F. Perform promise then evaluate promise on fulfilled on rejected. G. Return unu said link and evaluate be create built-in function link and evaluate closure 0. Let perform promise then load promise link and evaluate On rejected, return unused. ECMA International 2024 267, the 13th of March 2011 tagged templates. 3.3.1.1. 1 runtime semantics. Evaluation, member expression template literal, let tag ref be. Evaluation of member expression, let tag func be. Get value, tag ref, let this call be this member expression, let tail call be is in tail position. This call, return, evaluate call, tag func, tag ref, template literal, tail call expression template literal, let tag ref be. Evaluation of call expression, let tag func be. Get value, tag ref, let this call be this call expression, let tail call be is in tail position. This call, return, evaluate call, tag func, tag ref, template literal, tail call, the 3rd of March 2012 meta properties. 3.3.1.2. 1 runtime semantics. Evaluation, new target 1. Return get new target, import meter, let module be get active script for module, assert. Module is a source text module record. Let import meter be module. If import meter is empty, then A set import meter to ordinary object create. Null. B let import meter values be host get import meter properties, module. C for each record. P of import meter values, do. I perform. Create data property or throw, import meter. P. D perform host finalize import meter, module. E set module to import meter. F return import meter. Else. A assert. Import meter as an object. B return import meter. 3.3.1.2. 1 host get import meter properties, module record. The host defined abstract operation host get import meter properties takes argument module record, a module record, and returns a list of records with fields, an ECMA script language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1.3.2.8. The actual arguments include a template object 1.3.2.8.4. and the values produced by evaluating the expressions embedded within the template literal. 68. Copyright sign, ECMA International 2024, 1.3.3.1.2.1. To host finalize import meter, module record. The host-defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMA script code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await. Left-hand side expression yield await. Left-hand side expression yield await. Left-hand side expression yield await. ++ unary expression yield await. Unary expression yield await. 1.3.4.1 Static semantics. Early errors. Update expression. Left-hand side expression ++. No line terminator here. ++. No line terminator here. Left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3.4.2 Postfix increment operator 1.3.4.2.1 Runtime semantics. Evaluation. Update expression. Left-hand side expression ++. Let LHS be. Evaluation of left-hand side expression. Let old value be. To numeric. Get value, LHS. If old value is a number, then A let new value be number. Add old value. 1. Else. A assert. Old value is a begint. B let new value be begint. Add old value. 1Z perform. Put value, LHS, new value, return old value, ECMA International 2024 269, 13, 4, 3 postfix decrement operator 13, 4, 3, 1 runtime semantics, evaluation, update expression, left-hand side expression, let LHS be. Evaluation of left-hand side expression, let old value be. To numeric. Get value, LHS. If old value is a number, then A let new value be number. Subtract, old value. 1 else, A assert. Old value is a bigint. B let new value be bigint. Subtract, old value. 1z perform. Put value, LHS, new value. Return old value. 3, 4, 4 prefix increment operator 1 3, 4, 4, 1 runtime semantics. Evaluation, update expression, plus unary expression, let x be. Evaluation of unary expression, let old value be. To numeric. Get value, expa. If old value is a number, then A let new value be number. Add, old value. 1 else, A assert. Old value is a bigint. B let new value be bigint. Add, old value. 1z perform. Put value, expa. New value, return new value. 3, 4, 5 prefix decrement operator 1 3, 4, 5, 1 runtime semantics. Evaluation, update expression, unary expression, let x be. Evaluation of unary expression, let old value be. To numeric. Get value, expa. If old value is a number, then A let new value be number. Subtract, old value. 1 else, A assert. Old value is a bigint. B let new value be bigint. Subtract, old value. 1z perform. Put value, expa. New value, return new value. 70. ECMA International 2024 13.5 Unary operators syntax. Unary expression, yield, await. Update expression yield await delete unary expression yield await. Void unary expression yield await. Type of unary expression yield await. Plus unary expression yield await. Unary expression yield await. Unary expression yield await. Unary expression yield await. Plus await. Await expression yield. 3, 5, 1 that delete operator. 3, 5, 1. 1 static semantics. Early errors. Unary expression. Delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identifier reference. Member expression. Member expression. Private identifier. Call expression. Call expression. Private identifier. Optional chain. Private identifier. Or optional chain. Optional chain. Private identifier. It is a syntax error if the derived unary expression is primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, and capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1, 2 runtime semantics. Evaluation, unary expression, delete unary expression, let ref be. Evaluation of unary expression, if ref is not a reference record, return true. If is unresolvable reference, ref, is true, then A assert. Ref is false. B return true. If is property reference, ref, is true, then A assert. Is private reference, ref, is false. B if is super reference, ref, is true. Throw a reference error exception. C let base OBJ be. To object, ref, D let delete status be base OBJ, Ref, if delete status is false and ref is true, throw a type error exception. F return delete status. Else, A let base be ref, B assert. Base is an environment record. C return base delete binding. Ref, the last rule means that expressions such as delete foo produce early errors because. Note, a recursive application of the first rule, ECMA International 2024-271. Note 1 when a delete operator occurs within strict mode code, a syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note to the object that may be created in step 4C is not accessible outside of the above abstract operation and the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. 3, 5, 2 the void operator. 3, 5, 2, 1 runtime semantics. Evaluation, unary expression, void unary expression, let exp be. Evaluation of unary expression, perform. Get value, expa, return undefined. 3, 5, 3 the TPF operator. 3, 5, 3, 1 runtime semantics. Evaluation, unary expression, type of unary expression, let val be. Evaluation of unary expression, if val is a reference record, then A if is unresolvable reference. Val is true. Return undefined. Set val to get value. Val if val is undefined. Return undefined. If val is null, return object. If val is a string, return string. If val is a symbol, return symbol. If val is a boolean, return boolean. If val is a number, return number. 0. If val is a bigint, return bigint. 1. Assert. Val is an object. 2. Note, this step is replaced in section B. 3, 6, 3, 3. If val has an internal slot, return function. 4. Return object. 3, 5. Or unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 272. ECMA International 2024. 1, 3, 5, 4, 1 runtime semantics. Evaluation, unary expression, plus unary expression, let exp be. Evaluation of unary expression, return, to number, get value, expa. 3, 5, 5 unary operator. 3, 5, 5, 1 runtime semantics. Evaluation, unary expression, let exp be. Evaluation of unary expression, let old value be. To numeric, get value, expa.
So, I don't know.
A return number.
I'm just taking what the chatbot gave me,
4.
and it should work.
Old value is a bigint. Return bigint.
All it does is like push on a new allocation,
Sets operand.
and if there's not enough memory,
Negates it.
it makes a new malloc, and then it copies over,
Minus.
but it calls realloc. So I think behind the scenes, it's up to the compiler to do a copy.
5, 6, 3, 5, 6.
So I gotta put a loop to like manually copy, since I'm not gonna, I don't know.
Of unary
I'm using like an aligned alloc. I don't know if there's like a re-aligned alloc. I'm not gonna look it up. I'm just gonna make a copy or have it loop through.
assert. Old value is a bigint.
So that's about it to the push call. I don't even know. It's like super simple.
Expression. Unary expression. 3, 5, 7.
So I like keep it simple from this point on
Semantics. Evaluation. Let exp be.
and not argue the chatbot.
Let old value be.
This chatbot sucks.
Get value.
Sucks a quad.
True. Return false. Return true.
Because a quad is two triangles,
Syntax. Exponentiation.
not like a quad. I mean like a GPU quad.
Tilde weight.
Quadrant? I don't know, whatever.
International 2024 273. 1, 3, 6. 1 runtime semantics. evaluation, exponentiation expression, update expression, exponentiation expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, update expression, exponentiation expression, 3.7 multiplicative operators syntax, multiplicative expression, yield, await, exponentiation expression yield await, multiplicative expression yield await, multiplicative operator, exponentiation expression yield await, multiplicative operator, 1 of, percent, 3, 7, 1 runtime semantics, evaluation, multiplicative expression, multiplicative expression, multiplicative operator, exponentiation expression, let op text be the source text matched by multiplicative operator, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, mu, multiplicative expression, op text, exponentiation expression, 3.8 additive operators syntax, additive expression, yield, await, multiplicative expression yield await, additive expression yield await, plus multiplicative expression yield await, additive expression yield await, multiplicative expression yield await, 3, 8, 1 the addition operator, plus, note the addition operator either performs string concatenation or numeric addition, 3, 8, 1, 1 runtime semantics, evaluation, additive expression plus multiplicative expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, plus, multiplicative expression. Note, the operator performs multiplication, producing the product of its operands. The operator performs division, producing the quotient of its operands. The percent operator yields the remainder of its operands from an implied division. 274. Copyright sign, ECMA International 2024. 138. To the subtraction operator. 3, 8, 2, 1 runtime semantics, evaluation, additive expression, multiplicative expression.
My new vector's made.
L, U,
I might as well just make one.
E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, multiplicative expression, 3.9 bitwise shift operators syntax, shift expression, yield, await, additive expression yield await, shift expression yield await,
So here it calls.
await, shift
Let's make it a vector.
await, additive expression yield await, shift expression
Or optional. You type whatever.
3, 9, 1 the left shift operator, 3,
You need to rename optional to vector.
semantics,
And then 32T like you succeed.
additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression, 3, 9, to the signed right shift operator, 3, 9, 2, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R.
I don't want to assign initial values.
3 the unsigned right shift.
I want it to be like whatever it's called first is the state that it is.
Brands. Note performs a bitwise.
So I won't have to like undergo initialization until it's like access.
Bitwise right shift top.
But I don't want it to have to like initialize it until something's done, an operation that like actually needs it to be modified.
Operand. ECMA International 2024 275 1393 1 Runtime Semantics. Evaluation. Shift expression. Additive expression. Return. Capital E A L U A T
Like when it's instantiated,
R I N G
I don't want to like touch memory at all.
M E R
Just like leave it, and then like only ever when
A R
something needs to actually be assigned is when it'll be like assigned.
expression. 3.10 relational operators. Syntax. Relational
So that makes a huge difference in performance.
expression yield await. Relational expression in yield. Relational expression in yield. Relational expression in yield. Relational expression in yield.
It's like waiting to only use memory when it's being used.
Expression yield await. Shift expression yield await. Equals shift expression yield await. Equals shift expression yield await. Instantiaf. Note 1. The result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression yield await, plus in relational expression, plus in yield await, in shift expression yield await, plus in private identifier in shift expression yield await. 3. 1 0 1 runtime semantics. Evaluation. Relational expression.
Alright, so now it makes vector type.
Expression. Let left be. Evaluation of relational expression. Let level be. Get value. Ref. Let ref be. Evaluation of shift expression. Let reval be. Get value. Ref. Let r be. Is less than. Val. Reval. True. If r is undefined. Return false. Otherwise. Return r. Relational expression. Relational expression. Shift expression. Let left be. Evaluation of relational expression. Let level be. Get value. Ref. Let ref be. Evaluation of shift expression. Let reval be. Get value.
You should probably just initialize it to 0 and not play games with like
Undefined. Return false.
leaving garbage values in memory.
Relational expression equals shift
It's easier to like just count things being 0 anyways.
expression. Let level be. Get value. Ref. Let ref be. Evaluation of shift expression. Let ref
So leave it how it is.
value. Ref. Let r be. Is less than. Reval. Val. False. If r is either true or undefined. Return false. Otherwise. Return true. 276. ECMA International 2024. Note to the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement. Relational expression equals shift expression. Let left be. Evaluation of relational expression. Let level be. Get value. Ref. Let ref be. Evaluation of shift expression. Let reval be. Get value. Ref. Let r be. Is less than. Val. Reval. True. If r is either true or undefined. Return false. Otherwise. Return true. Relational expression instantia of shift expression. Let left be. Evaluation of relational expression. Let level be. Get value. Ref. Let ref be. Evaluation of shift expression. Let reval be. Get value. Ref. Return. Instantia of operator. Val. Raval. Relational expression in shift expression. Let ref be. Evaluation of relational expression. Let level be. Get value. Ref. Let ref be. Evaluation of shift expression. Let reval be. Get value. Ref. If reval is not an object, throw a type error exception. Return. Has property. Reval. To property key. Leval. Relational expression. Private identifier in shift expression. Let private identifier be the string value of private identifier. Let ref be. Evaluation of shift expression. Let reval be. Get value. Ref. Capital I. F reval is not an object. Throw a type error exception. Let private env be the running execution context's private environment. Let private name be resolve private identifier. Private env. Private identifier. If private element find. Reval. Private name is not empty. Return true. Return false. 3, 1, 0. 2 instantiaf operator. V. Target. The abstract operation instantiaf operator takes arguments v, an ECMA script language value, and target an ECMA script language value, and returns either a normal completion containing a... It implements the generic algorithm for determining if v is an instance of
Alright, so
target sat at has instance method or
I guess the first thing I should do
target's prototype
is assign a value
it performs
to the vector type.
not an object. Throw a type error exception. Let instf handler be.
Finally at the point where we can fucking populate the data.
Then a return to boolean. Call instf handler target v if is callable. Target is false. Throw a type error exception. Return ordinary has instance target v. Note steps 4 and 5 provide compatibility with previous editions of ECMA script that did not use a at has instance method to define the instantiaf operator semantics. If an object does not define or inherit at has instance, it uses the default instantiaf semantics. ECMA International 2024 277 13.11 Equality operators. Syntax. Equality expression in
And
relational
almost at 11 hours.
equality expression in yield await equals relational expression in yield await equality expression in yield await equals relational expression in yield await equality expression in yield await equals
Alright, so
in yield await
one push value.
yield await
What was it?
expression in yield await 3 1 1 1 runtime semantics evaluation equality expression
Oh, pushback.
let lef be evaluation of equality expression let level be get value ref let ref be evaluation of relational expression let reval be get
Alright, so that means the index is not specified.
reval
I think, I'd assume.
equality expression equals relational expression let ref be evaluation of it
I think.
get value ref let ref be evaluation of relational expression let reval be get value ref let r be is loosely equal reval leval if r is true return false otherwise return true equality expression equals relational expression let ref be evaluation of equality
Pressure.
get value ref let ref be evaluation of relational expression let reval be get value ref return is strictly equal reval leval equality expression equals let ref be evaluation of equality expression 2 let level be get value ref let ref be evaluation of relation
How the heck do you access it?
get value ref let r be is strictly equal reval leval if r is true return false otherwise return true 278 ECMA International 2024 note the result of evaluating an equality operator is always of type boolean reflecting whether the relationship named by the operator holds between its two operands. Note 1 given the above definition of equality, string comparison can be forced by $. equals $sign b. Numeric comparison can be forced by plus or equals plus b. Boolean comparison can be forced by it equals b. Note to the equality operators maintain the following invariants. A equals b is equivalent to a equals b. A equals b is equivalent to b equals a, except in the order of evaluation of a and b. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string a equals a and a equals new string a are both true. New string a equals new string a is false. Note for comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 Binary bitwise operators syntax. Bitwise and expression in yield, await. Equality expression in yield, await. Bitwise and expression in yield, await. And equality expression in yield, await. Bitwise or expression in yield, await. Bitwise and expression in yield, await. Bitwise or expression in yield, await. Bitwise and expression in yield, await. Bitwise or 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 expression in yield, await. 3. 1 2 1 Runtime semantics. Evaluation. Bitwise and expression. Bitwise and expression and equality expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Bitwise and expression and equality expression. ECMA International 2024 279. Bitwise or expression. Bitwise or expression. Bitwise and expression. Return. Capital E V A L U A T E. Capital R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Bitwise or expression. Bitwise and expression. Bitwise or expression. Bitwise or expression. Return.
I can't just like
V
simply access it.
U A T E. Capital S T R I N G. Capital O
So I need to bounce check.
U M E.
It's having a length. It's not a length. The compiler doesn't give access.
Bitwise or expression.
That's tough. I just modify it.
3.13.
So I gotta like,
Syntax.
I guess use mode 3.
Yield, await. Bitwise or expression in yield, await. Logical and expression in yield, await. And between. Set or expression in yield, await. Logical or expression in yield, await. Logical and expression in yield, await. Logical or expression in yield, await. Logical and expression in yield, await. Coalesce expression in yield, await. Coalesce expression head in yield, await. Bitwise or expression in yield, await. Coalesce expression head in yield, await. Coalesce expression in yield, await. Bitwise or expression in yield, await. Short circuit expression in yield, await. Logical or expression in yield, await. Coalesce expression in yield, await. 3. 1 3 1 Runtime semantics. Evaluation. Logical and expression. Logical and expression and bitwise or expression. Let lf be. Evaluation of logical and expression. Let leval be. Get value. Ref. Let label be to boolean. Val if a bool is false, return val, let ref be. A bitwise or expression, return, get value, ref, logical or expression, logical or expression, logical and expression, let ref be. Evaluation of logical or expression, let val be. Get value, ref, let a bool be to boolean, val, if a bool is true, return val, let ref be. Evaluation of logical and expression, return. 280, ECMA International 2024. The value produced by a and/or operator is not necessarily of type Boolean. The value produced, note, will always be the value. Coalesce expression head, bitwise or expression, let ref be. Evaluation of coalesce expression head, let val be. Get value, ref, if all values either undefined or null, then a let ref be. Evaluation of bitwise or expression be return. Get value, ref, else a return val. 3.14 conditional operator, syntax, conditional expression, in, yield, await, short circuit expression in yield await, short circuit expression in yield await, assignment expression, plus in yield await, assignment expression in yield await. 3, 1, 4, 1 runtime semantics, evaluation, condition, short circuit expression, assignment expression, let ref be. Evaluation of short circuit expression, let val be to boolean. Get value, ref, if all val is true, then a let true ref be. Evaluation of the first assignment expression be return. Get value, true ref, else a let false ref be. Evaluation of the second
Have this.
return.
That's the on the left.
Grammar for a condition.
This thing here.
MA script is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMA script is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusion.
So this is like the this argument. It needs to type.
2024 281.
Pick modes. 0, 1, 2, 3.
Syntax. Assignment expression in yield await.
I don't want to change it.
In yield await plus yield. Yield expression in await. Arrow function in yield await. Async arrow function in yield await.
1 means out.
Equals assignment expression in yield await.
In.
Expression yield await. Assignment operator assignment expression in yield
Out.
expression yield await.
Hold on.
Assignment expression in yield await. Left hand side expression yield await. Equals assignment expression in yield await. Left hand side expression yield await equals assignment expression in yield await. Assignment operator, one of, equals.
2 means in. So 1 means out.
Equals, equals, equals and equals 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 equals. 3, 1, 5, 1 static semantics. Early errors. Assignment.
So 2 means source. It's being assigned.
If
1 means out. It's getting the value and passing it out.
the following early error rules are applied, left hand side expression must cover an assignment.
So 1 is getting
Is neither an object literal nor an array.
from this.
Error rule is applied. It is a syntax error if assignment target type of left hand side expression is not simple. Assignment
And in is set
side expression is
to
left hand
upon.
and equals a
So set for letters.
side expression equals assignment expression left hand side expression
Set upon.
syntax error if assignment target type of left hand side expression is not simple. 3, 1, 5, 2 runtime semantics. Evaluation assignment expression left hand side expression equals
Let's do into.
82. If left hand side expression is
Alright, so
nor an array literal, then a let ref be.
1 means out. To get from whatever this is.
Expression
This is the left hand side.
left hand side expression
2 means to set.
a let ref be. Named evaluation of assignment expression with argument ref.
Into it. So it's setting to it.
Assignment expression 2. Let ref be. Get value, ref, deeper form. Put value, ref, Reval. Return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024. 3. Let ref be. Evaluation of assignment expression. Let reval be. Get value. Ref. Perform. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. Of assignment pattern with argument reval. Return reval.
And then 3 means it's setting
Assignment operator assignment.
plus getting the value and then setting one.
Evaluation of
So it's like overlap.
let level be. Get value. Ref. Let ref be. Evaluation of assignment expression. Let reval be. Get value. Ref. Let assignment op text be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment op text in the following table. Assignment op text equals percent equals percent plus equals plus equals 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 and equals and equals equals. Let R be. Capital A P P L Y. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital O P E R. Vowel. Op text. Reval. Perform. Put value. Ref. R. Return R.
The index here
Left hand side.
means how many of these, whatever.
Ref B. Evaluation of left.
It doesn't mean to access this. It means to access how many this is. So I have like 2, 4, 5 of this, except that this is.
True and is identify ref of left.
So it's not an array access.
I let reval be.
That's why I pick a different one.
Assignment expression with argument ref. Else. A let ref be. Evaluation of assignment expression. B let reval be. Get value. Ref. Perform. Put value. Ref. Reval. Return reval. Assignment expression. Left hand side expression equals assignment expression. Let ref be. Evaluation of left hand side expression. Let level be. Get value. Ref. Let bool be to boolean. Level. If a bool is true. Return level. If is anonymous function definition. Assignment expression. Is true and is identify ref of left hand side expression is true. Then a let reval be. Named evaluation of assignment expression. Else.
I need to be able to
Of assignment
pass in an indice.
Get value. Ref. ECMA International 2024 208.
And then pass in
Perform. Put value.
the in or out.
Reval. Return reval. Assignment expression.
2 things I need.
Expression equals assignment expression. Let ref be. Evaluation of left hand side expression. Let level be. Get value. Ref. If val is neither undefined nor null. Return level. If is anonymous function definition. Assignment expression. Is true and is identify ref of left hand side expression is true. Then a let reval be. Named evaluation of assignment expression with argument ref. Else a let ref be. Evaluation of assignment expression. B let reval be. Get value. Ref. Perform. Ref. Reval. Return reval. 3. 1 5.
So maybe I make 3.
P L Y. Capital S T R I N G. Capital O.
The indice in.
U M E R I C. Capital B.
And 0 to be indice out.
A R Y. Capital O P E R. Vowel. Op text. Reval. The abstract operation. Capital A P P L Y. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital O P E R. takes arguments val, an ECMA script language value, op text, comma percent, plus, and, or, and reval, an ECMA script language value, and returns either a normal completion containing either a string, a big int, or a number, or a throw completion. It performs the following steps when called if op text is to primitive, val, b let reprim b, to primitive, reval, see if a prim is a string or a prim is a string, then I let lstrb, to string, prim 2, b, to string, reprim 3, return the string concatenation of lstr and rstr, dset reval to prim, eset reval to reprim, note.
Which means this is what's access. Access whatever.
Reval, letter number, to numeric, reval, if type.
Guys.
Not type, renum, throw a type error exception. If num is a big int, then, note when this expression
I just gotta make this work. I don't want to change it.
is a runtime error if a
I'm not gonna change it.
to is an unresolvable reference. If it is, a reference error exception is thrown.
3 is this and dice, but in.
Error if
So this would be the variable to sign out to whatever's at this and dice.
false, to an access.
And this one is at this, the indice, for what to assign to it.
Renum, if op text is comma return, begint, divide, num, renum, if op text is percent, return, begint, remainder, num, renum, if op text is, return, begint, and signed right shift, num, renum, operation be the abstract operation associated with op text and type, num. In the following table, 84, ECMA International 2024, op text type, num, operation, number, exponentiate number, multiply begint, multiply number, divide number, remainder number, add, percent plus, number begint number, op text type, num, plus begint, number begint, comma number begint, operation, begint, add number, subtract begint, subtract number, left shift begint, left shift number, signed right shift begint, signed right shift number, and signed right shift number, bitwise and begint, bitwise and number, bitwise or begint, bitwise or number, bitwise or begint, bitwise or return.
I can't make
No hint is
one of the extra parameters, the indice, or the value, that's assigned or passed out.
as if number
I have to make those the fast variables, the ones that aren't copied.
may handle the absence of a hint in some other manner. Note 2 Step 1c differs from Step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A,
Like
A, T,
modifier flags or whatever,
R,
those could be copied.
capital O, R,
It's unfair
U, M, E, R, I,
because I don't want to like destroy or decay the pointer to
left up,
the in or the out or the indice that's picked.
operation, cap,
That needs to stay a literal like replacement
A,
like as it is. But if a flags field or whatever is assigned a copy,
capital N, U, M,
that won't have as big as an effect.
N, A, R, Y, capital E,
And it's not as much as a pain because the indice might be a literal or a value. And if I have to assign it to another value, then like the sign of the value, if it's like signed or not,
when called
or the size T, that all becomes a big deal.
LB,
But if it's like a bit field, I'll just like define it as a literal.
turn,
And it's not that like difficult to assign it to temporary
E, R,
if passed in.
G, O-R, capital N-U-M-E-R-I-C, capital B-I-N-A-R-Y,
So I was going to use 0.
vowel, op text, raval. 3, 1, 5. 5 Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production
To indicate 0 arguments.
assignment expression, the
But no, I think I gotta use it to indicate
ma assignment
2 parameters to mirror 3.
pattern yield await. Array assignment pattern yield for 285. Object assignment pattern yield await. Assignment rest property yield await. Assignment property list yield await. Assignment property list yield await. Assignment rest property yield await. Opt array assignment pattern yield await. Elision not assignment rest element yield await. Opt assignment element list yield await. Assignment element list yield await. Elision not assignment rest element yield await. Opt assignment rest property yield
And what do I return? In out.
target yield await. Assignment property list yield await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list yield
A pointer.
elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element yield await. Elision not assignment element yield await. Assignment property yield await. Identifier reference yield await. Initializer plussing yield await. Up property name yield await. Assignment element yield await. Assignment element yield await. Destructuring assignment target yield await. Initializer plussing yield await. Opt assignment rest element yield await. Dart destructuring assignment target yield await. Destructuring assignment target yield await. Left hand side expression yield await. 3, 1, 5, 5, 1 static semantics. Early errors. Assignment property. Identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment rest property.
Man.
It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target left hand side expression. If left hand side expression is either an object literal or an array literal, the following early error rules are applied. Left hand side expression must cover an assignment pattern. If left hand side expression is neither an object literal nor an array literal, the following early
So like pushback 3 and dice 69 with set 69 to this and dice.
syntax error if assignment
You get like 5 or something.
not simple 1 3 1
And then pushback 0.
semantics.
I pick 5.
STRUCTURING capital ASSIGNMENT
Oh man.
ALUAT. The syntax directed operation capital DESTRUCTURING capital ASSIGNMENT capital EVALUAT takes argument value and is
Alright, if I do like 0, 5, then it has to be assigned to like some of their
on you store in a
like result here.
over the following productions. Object
So this would like assign 69 to result here.
value return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object coercible. Value perform. Capital PROPERTY. Capital DESTRUCTURIN.
But if I pass back a pointer to it,
NME
it's possible it could have resized before I access pointer.
Object assignment pattern. Assignment rest property. Perform.
So we need like a base and an offset.
Included names be a new empty list.
Stored to a struct.
Capital R E S T capital D
And then it'd be forced
T R
to update it
T
unless it held like a registry of everything that's accessed,
S
and then loop through and reassign them.
N M E N T capital E V A of assignment rest property with arguments value and excluded names. Object assignment pattern. Assignment property list. Assignment rest property. Perform. Require object coercible. Value. Let excluded names be. Capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M.
Damn it.
Assignment property list with argument value. Return capital R E S T
I'm gonna need to figure out
E S T R U C T
how to pass in a property.
G capital A S S I G N M E
A property chain.
E capital E V A of assignment rest property with arguments value and excluded names. Array assignment pattern. Let iterator record be. Get iterator value sync return iterator close iterator record normal completion unused array assignment pattern elision. Let iterator record be. Get iterator value sync. Let result be completion iterator destructuring assignment evaluation of elision with argument iterator record. If iterator record is false, return iterator close iterator record result return result array assignment pattern elision not assignment rest element. Let iterator record be. Get iterator value sync. If elision is present, then a let status be completion iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. Let result be completion iterator destructuring assignment evaluation of assignment rest element with argument iterator.
I need some water. I gotta think.
287 4.
I gotta come up with like a funky solution just to get it done.
Result. Return result. Array assignment pattern. Assignment element list. Let iterator record.
So I don't want to do this anymore.
Iterator value sync. Let result be completion iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return iterator close iterator record result return result array assignment pattern assignment element list elision not assignment rest element topped. Let iterator record be. Get iterator value sync. Let status be completion iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then a if iterator record is false, return iterator close iterator record status. B return status. If elision is present, then a set status to completion iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment rest element is present, then a set status to completion iterator destructuring assignment evaluation of assignment rest element with argument iterator record. 6. If iterator record is false, return iterator close iterator record status. Return status. 3. 1 5 5 3 runtime semantics. Capital P R O P E R T Y capital D E S T R U C T U R I N G capital A S S I G N M E N. The syntax-directed operation, capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, takes argument value, an ECMA script language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all destructured property keys. It is defined piecewise over the following productions: assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property, identifier reference initializeropt. Let P be string value of identifier reference. Let LF be resolve binding P. Let V be jet value P if initializer is present and V is undefined. Then A if is anonymous function definition, initializer, is true. Then I set meter named evaluation of initializer with argument P. B else I let default value be evaluation of initializer. 2. Set meter get value, default value, perform put value, ref V, return P. 88, ECMA International 2024. Assignment property, property name, assignment element. Let name be evaluation of property name. Perform capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V, of assignment element with arguments value and name. Return name. 3 1 5 5 4 runtime semantics. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A, the syntax-directed operation, capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A, takes arguments value, an ECMA script language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment rest property, destructuring assignment target. Let LF be evaluation of destructuring assignment target. Let rest obj be ordinary object create %object prototype %perform copy data properties. Rest obj value excluded names. Return put value ref rest obj 3 1 5 5 5 runtime semantics. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N the syntax-directed operation, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment element list, assignment deletion element, return, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, of assignment elision element with argument iterator record, assignment element list, assignment element list, assignment elision element, perform, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, of assignment element list with argument iterator record, re2 RN, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, of assignment elision element with argument iterator record, assignment elision element, assignment element, return, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, of assignment element with argument iterator record, assignment elision element, elision assignment element, perform, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, of elision with argument iterator record, return, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, of assignment element with argument iterator record, elision. If iterator record is false, then A let next to be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true, C return if abrupt. Next, D if next is false, set iterator record to true, return unused, elision, elision, perform, capital I-T-E-R-A-T-O-R, capital D-E-S-T-R-U-C-T-U-R-I-N-G, capital A-S-S-I-G-N-M-E-N, of elision with argument iterator record. If iterator record is false, then A let next to be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. ECMA International 2024 289, C return if abrupt. Next, D if next is false, set iterator record to true 3. Return unused, assignment element, destructuring assignment target initial is erupt. If destructuring assignment target is neither an object literal nor an array literal, then A let ref be. Evaluation of destructuring assignment target, let value be undefined. If iterator record is false, then A let next B. Iterator step value, iterator record. B. If next is not done, then I set value to next. If initializer is present and value is undefined, then A. If is anonymous function definition, initializer, is true and is identify ref of destructuring assignment target is true, then I'll add PB. Named evaluation of initializer with argument ref B else. I let default value be. Evaluation of initializer 2. Let VB. Get value, default value else. A. Let VB value. If destructuring assignment target is either an object literal or an array literal, then A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target be return capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument V return put value ref V assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then A let ref B. Evaluation of destructuring assignment target. Let A be array create 0 let 0 repeat while iterator record is false. A let next be iterator step value iterator record. B. If next is not done, then I perform create data property or throw A to string N next 2. Set enter N plus 1. If destructuring assignment target is neither an object literal nor an array literal, then A return put value ref A. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target return capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument A 3 1 5 5 6 runtime semantics capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V. The syntax directed operation capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V takes arguments value, an ECMA script language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element. Destructuring assignment target initial is erupt. If destructuring assignment target is neither an object literal nor an array literal, then A let ref B. Evaluation of destructuring assignment target let VB. Jet value property name. If initializer is present and V is undefined, then 290 ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. A. If is anonymous function definition, initializer, and is identify ref of destructuring assignment target are both true, then I let RHS value be. Named evaluation of initializer with argument ref B else. I let default value be. Evaluation of initializer 2. Let RHS value be. Get value, default value else. I let RHS value be V. If destructuring assignment target is either an object literal or an array literal, then I let assignment pattern be the assignment pattern that is covered by destructuring assignment target be return capital D E S T R U C T U capital A S S I G N M E N T capital E V A L U A T of assignment pattern with argument RHS value return put value ref RHS value 3.16 operator syntax expression in yield await assignment expression in yield await expression in yield await assignment expression in yield await 1316 1 runtime semantics evaluation expression assignment expression let ref be evaluation of expression perform get value ref let ref be evaluation of assignment expression return get value ref for ECMA script language statements and declaration syntax statement yield await return block statement yield await return variable statement yield await empty statement expression statement yield await if statement yield await return breakable statement yield await return continue statement yield await break statement yield await plus return statement yield await with statement yield await return labeled statement yield await return throw statement yield await try statement yield await return debugger statement note get value must be called even though its value is not used because it may have observable side effects ECMA International 2024 291 declaration yield await hoistable declaration yield await default class declarer Cheyenne yield await default lexical declaration plus in yield await hoistable declaration yield await default function declaration yield await default generator declaration yield await default async function declaration yield await default async generator declaration yield await default breakable statement yield await return iteration statement yield await return switch statement yield await return 4.1 statement semantics 4.1 runtime semantics evaluation hoistable declaration generator declaration async function declaration async generator declaration return empty hoistable declaration function declaration return evaluation of function declaration breakable statement iteration statement switch statement let new label set be a new empty list return labeled evaluation of this breakable statement with argument new label set 4.2 block syntax block statement yield await return block yield await return block yield await return statement list yield await return opt statement list yield await return statement list item yield await return statement list yield await return statement list item yield await return statement list item yield await return statement yield await return declaration yield await 92 ECMA International 2024 142 1 static semantics early errors block statement list it is a syntax error if the lexically declared names of statement list contains any duplicate entries it is a syntax error if any element of the lexically declared names of statement list also occurs in the var declared names of statement list 4.2 runtime semantics evaluation block return empty block statement list let hold env be the running execution context's lexical environment let block env be new declarative environment hold env perform block declaration instantiation statement list block env set the running execution context's lexical environment to block env let block value be completion evaluation of statement list set the running execution context's lexical environment to old env return block value statement list item let SL be evaluation of statement list let S be completion evaluation of statement list item return update empty S SL 4.2 3 block declaration instantiation code env the abstract operation block declaration instantiation takes arguments code a parse node and env a declarative environment record and returns unused code is the parse node corresponding to the body of the block. env is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private env be the running execution context's private environment. For each element D of declarations, do A for each element Dn of the bound names of D. D.O. ECMA International 2024 293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function or return the value 1 eval, 1 eval, 1 eval, 1 var a. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scope variable, constant, function, or class declared in the block or instantiated in the environment record. If is constant declaration of D is true, then perform env create a mutable binding, dn, true. 2. Else, perform env create mutable binding, dn, false. Note, this step is replaced in section B, 3, 2, 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding, fn, fo. Note, this step is replaced in section B. 3, 2, 6. Return unused 4.3 declarations and the variable statement. 4, 3, 1. Syntax, lexical declaration, in, yield, await. Let or const binding list in yield await.
stream's almost at 12 hours. And there's no way I'm gonna like quickly figure this out. I can't pass in a property chain here because these are initialized by default. I might be able to there might be a way to pass in group up parameters again, or add a third arc. That'll take like 40 minutes though, and I have to adjust it to only do it for this type and leave the other types how they are, which I can do, which might make more sense. Or I can maybe pass it in after this property. I gotta pick some. There's no way I can do it before the stream's over. I'm not gonna bother to edit the code right now. So I'm like, wrap this as off. Should still build. And it still builds. Hooray. I don't have to like undo anything. Alright, so this is like turned off. And everything else is fine how it is because I didn't change it. I just like added stuff in here. So I'm gonna save this, save it back up. Then finish this up tomorrow. And I should be able to get this stuff in place tomorrow running. And maybe half of the file, if not all of it. Maybe half the file. I still gotta like merge the initialization parts that do this with the tutorial parts. Because it's not the same. It's not like exactly the same. Because his tutorial stuff for Windows. And this is Linux. So it's like, that'll be annoying. This freaking sucks. So I don't know. Pick up tomorrow, guys. Some of the stream run out for 10 more minutes because it doesn't always send the whole stream. So if I let it run out for 10 minutes, it might send the whole stream. And I don't know. Tomorrow, whatever. Peace.
ECMA script function objects have the internal method defined here. ECMA script functions that are also constructors in addition have the internal method 0, 2, 1. This argument, arguments list. The internal method of an ECMA script function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If F is true, then A. Let error be a newly created type error object. B. Note. Error is created in callee context with F's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return if abrupt, result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments F, an ECMA script function object, a new target an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMA script code execution context. Set the function of callee context to F. Let callee realm be F. Set the realm of callee context to callee realm. Set the script or module of callee context to F. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env 0. Set the private environment of callee context to F 1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note. Any exception objects produced after this point are associated with callee realm. 4. Return callee context 0, 2, 1. To ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments F, an ECMA script function object, callee context, an execution context, and this argument, an ECMA script language value, and returns unused. It performs the following steps when called. Let this mode be F. If this mode is lexical, return unused. Let callee realm be F. Let local env be the lexical environment of callee context. If this mode is strict, then A. Let this value be this argument 6. Else, A. If this argument is either undefined or null, then I let global env be callee realm. 2. Assert. Global env is a global environment record. 3. Let this value be global env. B. Else, I let this value be. To object, this argument. 2. Note. To object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value 0. Return unused 0, 2, 1. 3. Runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions: function body, function statement list, return, Evaluate function body of function body with arguments function object and arguments list. Concise body, expression body, return. Evaluate concise body of concise body with arguments function object and arguments list. ECMA International 2024 177. Generated body, function body, return. Evaluate generated body of generated body with arguments function object and arguments list. Async generated body, function body, return. Evaluate async generated body of async generated body with arguments function object and arguments list. Async function body, return. Evaluate async function body of async function body with arguments function object and arguments list. Async concise body, expression body, return. Evaluate async concise body of async concise body with arguments function object and arguments list. Initializer, assignment expression, assert. Arguments list is empty, assert. Function object.